Yeah, hello everyone. TTS not working because we need a secure connection. I will do it now. So, I'm sorry. I will try to fix that. Where is it? Here. Alright. But I need to do it online. So, third bot. DNS record. I hope. Okay. Hello Dutch. Hello Osu. Hello Jordi. Hello Johnny. Hey IDDT. Unfortunately, that will take a second. TTS won't work because the connection is not secure, but oh no. Where's my DNS entries here? DNS console will shut down? What? Okay, here, Acme challenge. I won't show it because I have like secure keys. Save. Okay. But I need someone would capture my domain otherwise. But it won't take long. I have unfortunately several wildcard domains, so I got things. I received items today, so we can check AliExpress shippings. Unfortunately, not a single soldering station arrived yet. I'm stressed now. Here, cheers, some booster. Oh, ice cold. Not sponsored. Okay, file system. Changing stuff here. Tools, file manager. Bop, ba-dap. I started to listen to techno while working again, and it's weird, but I really like it. Okay. Store. Okay, next one. I might even need to restart my Apache to be able to get a new certificate running. Whoop. Okay, next one. Creating files. Acme challenges to prove that the domain is mine here. I think that should be the last one. Yes. It's taking. Okay. Certificate will now blah blah blah. Okay, let's encrypt now servers, and then I will Apache web server. I will just renew. Apply changes. I hope it works. In a second, live chat will work again. Hey Christian, hey TMK, hey Sonic. Yeah, sorry, domain. I'm so bad. Last week I checked even for the certificates and thought, oh yeah, I will do it immediately, and then forgot about it again. Even if I put it in a calendar, I don't check my calendar, so I'm the worst. What is this? Where's the text window? The chat window is cut, or what? What's happening here? Huh? Weird. Alright. Cron job? How do you cron job that? You can cron job wildcard renew, or how do you do that? I mean, can you? I have like DNS with Hetzner, and I need like to add a text record at Hetzner, and I really don't want to store any passwords or anything anywhere. Hype train, what? What happened? Thank you, Christian, for subbing. Restart the web. Yeah, that's basically what happened right now. Okay, I will try again running the server. Okay, here. Okay. Wait, where is the auth? Yes, it worked. Nice. Okay. TTS should be working in a breeze. Yeah, it's secured connection again. Nice. Okay.
Nice.
Ah, here we go. I just need to connect my headphones and then we are ready. Ah, cheers, Prost. So, schedule today. We'll do some code testing and maybe some design later on.
Palm Johnny laughing face.
Okay, let me connect my phone.
Does THCT have alcohol?
THCT? What is T? That? No. That is not alcohol. That's alcohol free, but it has taurine. So, almost as good as alcohol. I hope it's... Where's my okay, here we go. Now I got you on my ears. Does it work? Yes. Alcohol's haram. Huh? Oh, IDT, you didn't know? Yeah, you can go to bitluni.net/chat HTML, and then you can turn on use connect chat, and oh, sub gift, Johnny, did you hear that? We had even we have sound effects. If you sub like Johnny gifting subs, you can get sounds on that TTS. Yeah, we're starting good with some trouble here. Anyways, we wanted to check some of the stuff that we ordered last time. Unfortunately, no soldering station. I have good news. I have some good news regarding the expensive power supply. Now that I bought one, you can have the other ones. So you remember the 3 kilowatt power supply? Yeah, I'm sending it back because I bought the last one that was available in stock in Germany, which cost me over $700, but now it's available at Pro Shop again for 400 whatever. So I'm sending this one back. Fortunately, it's possible, and I already bought the other one, so the other one will arrive. Like, it's the same thing, but it costs like almost $300 less. That's amazing. That's like free money glitch. Yeah. Yeah, that's how it works. Dodge Taurus, it's exactly like that, because I get a flat fee from the sponsor from Altium, and anything I don't spend on this ultra cluster I can keep. So basically that $300 I take it and I buy just some crap off AliExpress, like this stuff that I got today. That's not AliExpress. That's my here. No, here we go. Yeah, need more light. Let me turn that on here. It's not automated. We should automate it. Yeah, a little bit better. Okay, so I wanted some cheap alternative for my lighting. Look the lights. This is, I like the color fidelity that I get. Like it's the CRI value of these lights that are usually like you mount it on camera or whatever, and that's like camera mount here, or I use that. They are great, like but a little bit dim, and they are always in my way when I work here. It's like annoying me as F. So we got something new. Yes, I bought these here. Chat in a stream. Oh yeah. Let me refresh that. Yeah, chat is working. Here we go. Wait. Here we go. Ha! Yeah, it's working. It's working. Forgot to refresh the URL. The URL. All right. So we got these lamps. Let me put it on screen so we know what we are talking about. What price? I just bought. There are like $70. Good lights for microscope, but I didn't feel like that's a fair China price. So I bought these here for $6, my friends. These are $6 here. I don't know how you mount that. I have no clue what kind of mount that is. I can give you, yeah, here, share a link if you're interested. If they're crap or not. I know that they are quite where's here. So they come with on the back there is power, USB powered. Wait, is it on? No, we need some else because this power supply doesn't turn on. Okay, so this is yeah, that's TTS is just Google Translate or whatever. URLs. Here we go. Power supply. Broken. Doesn't work. Huh? Or is this not turned on? Ah. Huh? What's going on? Ah, yeah. Here we go. Here. So you have like, you can even change the brightness. It's quite bright. Look at that. Look at that. It's probably brighter than what I have right now. And it will, since these are spots, actual spotlights, I can focus that. Oh, there's a resistor. There's a 402 resistor. You can just spucks it here somewhere. Like, I don't know how that's meant to be mounted for whatever that's meant to be. Maybe for a laptop or something. You put it on top of a laptop, and then you have like extra USB hub here or power or whatever. It's weird. Yeah, for $6. Yeah, that's a SMD resistor. And I got a different one. This is even cheaper. Yeah, that's meant for PC, but you know, I don't care. If I can get rid of all this stuff and put it there, like get a spot, that's cool. I just need to adjust the white balance. It's probably like really cold. And I have this super cheap USB light for PC. Here. This is more a warmer kind of white, but I like it. I like it too. That's like, look at that. Yes, yeah, 2 zip ties. I would even like put a screw through that and bolt it somewhere there. Like I can put it here. Look at that. Ah, just squeeze it in between the camera and okay, maybe I should not the power line of the camera. Ah. Everything. Ah. Here. Okay. Let me remove that. Put it here. Just. Yeah, I need some spucks. Wait. Power supply. Yeah, I didn't get the power supply that I ordered yet. I don't know. Okay. Yeah! Yeah, look at that. Look at that. Let me move that away. Here we go. Let's start with that. And there is another one. Yeah, I can use that later. So this is now new spotlights. You can even use like, instead of these here, I mean I like the color temperature because you can set the color temperature of these here. And I even like put the for the arms, I put the hole here like a thread into the fume extractor. I built it myself. You can get this hose of AliExpress as well, but it's quite expensive. This hose alone costs $50 if you get it. Ah. Yeah, now you can see if you look, my plant died. It's dying. Losing leaves. I don't know what happened. Probably too much water. Yeah, here we go. Here we go. Let's see how bright it is. We can switch to the microscope. Oh, nothing. Yeah, let's turn on the camera first. Ah. Yeah, quite cold. Let me do a white balance. We can do a white balance. Let's full zoom in. Yeah, this is what I think. It's quite, you need to really, where's the 5? Need to aim everything at, yeah, it's brighter than the other one, certainly. With full zoom factor. Okay, let's do a white balance. Ow! Poked my eye. Okay, white balance. Okay. So this is an 04 or 2 O2 resistor. Where is it? Here. Here. Oh, can't go that low. Did I change it? Here. Okay. This is the. Okay. That's good. I would say that's a winner. Look at that. Oh wow. Perfect. Ah, finally. Oh, that's looking through the oculars is quite bright. This is more than I ever wanted. Oh, perfect. And I can use my hands freely around it. Okay. Amazing. Okay, this lights. Perfect. Hey DHC. Thanks for the bits. Yeah, I might need to adjust it a little bit. Wait. It's blowing out a little. I guess my lens might be dirty from all the fumes. Grow light. 65K is quite bright. Ah, okay. Grow light, $15. Yeah, I see that. All right. That's the first item of the list. The other order. What else did we get? Here, this is the other one. $1.79. Also cool. I like that little one. You can buy like 4 or 5 of those if you have like an. Yeah, I mean, I use an old USB power supply. If I buy 4 of those, we're also at $6, but we have no adjustment for the brightness. So, and there is no on-off switch. You can completely turn it down, but there is no switch with the other ones. Yeah, I guess it's just for laptop. And you have like an extra connector. Okay, now let's start with the first failure. Pink LED fund. I embezzled pink LED fund for this year. What is this? What is this? Here. Light. I can see that it's white. Is it pink? That looks white to me. It looks pink on cam. Okay, let me do a screenshot here. A hint of pink. Okay. Okay. We do an investigation here. Live investigation, peeps. Here we go. Okay. Paint.net. Yeah, we gone too far. Okay, now it looks pink. Huh? It's so weird. It's very faint. Very faint. I would say. Oh no, it is actually pink. What the Huh? In real life it looks like it's white. This is no pink. Let's see. Yeah, look at that. It's basically a light red. There is no. It's 28, 187, 185. Yeah, sunlight. Maybe we need some. Wait, you know what? Let me take my high CRI. Oh no, wait. These are high CRI lights that I'm using here in this room. Claim. Oh. Yeah, alright, but I like how it appears. It's actually rubbery. It's thick. I don't know if it's like a lot of silicone or what the deal is. But okay, do I have? How do I show it? Okay, here we go. Yes, it's silicone. It's actual silicone. Again, you can feel that. And here we go. Boop. And then let's plug in my headphone. Boop. And it shows 0 watts. Yeah, let me charge my phone. Here we go. 20 watts power delivery. PD 20 watts. That works. Cool feature. You don't use it in your sleeping room because it's funny with those two eyes here. I'm wondering if there is like a button below that and you can change settings or something. Didn't find anything on this. Manufacturer. Yeah, flexible silicone. Okay, so this was the pink cable. It wasn't very cheap. So if you're interested, I mean, very light pink, almost white. It appears. Drop you the link. You can think. Yeah, you should select longer though. I only picked by accident. I took only 1 meter. But it should be enough for the soldering iron. Yeah, that will be perfect. Okay. Okay. Here. Soldering iron tip refresher. Choop. We can try that. Okay, that arrived. Thank you for that. Then we have, okay, these come last, all right? These come last. Okay, I thought, I dropped something. All right, so this was cheap. It stinks. Okay, I will use my extractor. I thought, like, look at that. Yeah, I don't like it. This is like very thin. I thought I will get a proper plate or something. But these clamps are perfect. Like, they have like, this is neodymium magnets. Look at that. Whip, whip, whip. Little clamps. Clampy clamp. Doop. Here we go. Ah! Yeah, okay. You need to bend it in place first and then clamp it, otherwise it won't. Yeah, that's cool. I like it. And there are plenty of those. It's probably for repairing. Look at that. We have like two picks to open, I don't know, phone cases. Here we go. Little. $20 for the steel sheet. Where did you buy the IDT? Where did you buy the sheet? Yeah, this is. I need some like maybe thicker metal, because that box that sheet metal, it's so thin. But these are cool. I like that. Yeah, it's too thin. Home Depot. All right. Oh yeah, I can buy it at hardware store as well. All right, so this is the winner, I would say. These things, I wouldn't buy it with your case though. It's pointless. I think I paid extra because I thought it's like a metal plate, and it came bent. Look at that. Yeah, it was really dented. I mean, it's nice to put it there, but the blue thing, that's a pick. Yeah, this one. That's for opening cases or whatever. So you can pry open a phone or whatever. I think that's supposed to be like a repair kit or something. Anyways, that was that. I hope it improves the convenience of working with. Like, look at that. That's, oh no, it's dangling again. Like, you see that? Everything is dangling around. I want to, and every time, like, every cable is pulling it off the table. I even use clamps like that. Look at that here, to basically secure all the cables so they won't pull it off the table. But still, like, the scope, we'll need it later because we will scope today. Yeah, this is. Alright, what else did I get? Well, let's open this first. Magnifying glass. Yeah, I will use this microscope, but a magnifying glass sounds also cool. Alright, here is the repair. Yeah, it says the repair tool. Discount coupons? Where is it? Here. Here. 1 piece. 4 pieces. Yeah, 4 pieces is already cool. Oh, wait. Black. Hey, did I get this one? Yeah, these are longer ones. I don't know. Anyone interested in the link? I will just give it to you. Just don't get one with the box or whatever. Just get and $2. Look at that. Oh, eBay. Oh, yeah. But oh, they look like thicker. Maybe that they are even bigger with and there is a light, a ring light. $44. Interesting. Oh, wait. Welcome deal. No, 99 cents. Yeah. Take full slings then. Full welcome then. All right. What else did I get? I bought. I didn't read. I didn't read properly. I thought the soldering stations, they come like maybe with one tip or whatever. So Why is it so small? Enhance. Yeah, stupid. Look at that. They're probably awaiting flight. They probably meant to go over Bahrain or something, and there is no flight going to Bahrain. So, Tommy and system won't sign in. I hope they are doing well. Currently, the situation, political situation, it's just war. So, I said it. My LCSC parts went also over Bahrain. So I guess some of the items might be delayed. Yeah, I'm getting 2 new irons because I want like this one here. That's the C210 type, and this one that's the 115 type, C115 type. I just bought 2 soldering irons. That's it, and both are delayed. As is the power supply here for the other lights, and the clamps for power is also delayed. This also didn't arrive. Stereo soldering. Okay, I will show you why I bought the 2 soldering stations, because one is bigger and one is smaller, and I show you the difference. Because I didn't read, I mean, it's here. I don't know. Handle 3 tips. It says 3 tips. I didn't read that. So, no, it did no. Actually, it might go directly to Belgium. There are like different routes that China takes to transport stuff to, and they're taking flight. But if you, that's not like almost like the sea path. So if our mini excavator is probably delayed, if it's coming by ship, so I need to schedule that properly. But sometimes flights are going over like Bahrain or somewhere there in Arabic states, and that might not work right now. Ship monitor looks crowded. Oh, do you have a link, Sonic? Anyways, I bought 2 soldering irons because I show you why. I wanted 2 different sizes, and then we determined I don't want like to dick around with handles. Nothing useful for tight soldering. Yeah, so I thought they come without tips, so I bought 2 tips sets, and look at that. Yeah, look at that. Look at the size of this. Is the C115. This is the small type. What? Look at that! And probably more useful is the knife. I don't have a knife tip yet with none of my soldering irons. The TS90, look how thin that is. Let's compare with my current soldering iron, which made me okay. I mean, yeah. Look at compare the conical. This is the smallest tip that I have so far. So compare the angle of the. We need to switch to the microscope. Shall we switch to the microscope to enhance? Hey, Caspar. Here we go. Okay, so let's compare my soldering. This is a 0402 resistor here. So this is the small conical tip, the TS, no, there's C115 type. This is the conical tip of my current, of the TS90. This is, you don't see the scale. I will give you, what can I use for scale? Actual meter. Let me get a ruler. Here's a ruler, okay? Crocodile clamp, yeah, no, this doesn't fit on screen. Here's the ruler. That's 1 millimeter. 1 millimeter. Oh, it's too bright. The new lights are too bright. They're coming directly reflecting. Okay, here. Okay, so this is a ruler, and this is the TS. Yeah, this is what we try to use. Okay, I show you. We had the issue. Oh, this was running all the time. Okay. I had the issue to solder in between, like fix stuff in between those components. Look at that. Doesn't fit. Crap. I can't get this solder ball out there. But then we have the new knife tip here. New knife tip. Knife tip works. I can poke there around. So knife tip works, and conical tip will, yeah, conical, oh, I can put 2 conical tips in there. This is perfect. Yeah, so this is the small one. We can even enhance even more. Look at that. So you're able to see. This is like plenty of space now. Amazing. Love it. Look at that. Can work around there. Boop. My new tips. Perfect. Knife tip is so, I mean, you can use the knife tip probably like poke around like a conical, because it has a sharp end. But yeah, it's yeah, the soldering stations didn't arrive yet. It's only the tips that I got here. But these are this is the small size. Yeah, okay, let me turn down the lights a little. Yeah, dim the lights. Tip talk. Alright, so there is another one. Thermal mass. Yeah, large planes. Probably. That's why I have like 2 soldering stations. I ordered both of them. One for the thermal mass and one for the really narrow spaces. And I opened the other one. And this is the second. It's not bad either. This is the 210 size. So a little bit more thermal mass. You can see this, yeah, that they're way bigger compared. This is an 04 or 2 resistor here. You see that? So here. This is the 04 or 2 resistor, and I think even though with the 210 soldering iron I will be able to work, but this is like isn't that cool? That looks cool. Okay, so I will have 2 stations and I can turn them on simultaneously, and I can grab one, solder, and if it doesn't work I can grab the other one and solder and be good. no more dicking around with stuff, like trying to whatever. Like this is the TS90 that I used so far. I mean, I have some thermal mass there, and for comparison, the biggest tip I have is with my other soldering station. This is the this is the one that I use like for 12 gauge wire connectors or whatever. What is XT90 connectors. This is the other tip. Yeah, so I have now a size for everything. All right, so let me grab those because I got something else. Excavator. That's cool. I like the lights. The lights is a winner. $6. I'm amazed. Okay. Next item. Next item. These are the tips. Very tiny. Look at the size comparison here. Like these are almost twice as big as the other ones. Cool. This thing. It's a chunk of aluminium. And whoop. Finally I have some. Can put all my soldering iron tips there. Whoop. The smaller ones in front. Here we go. Just a block. I don't like the ad here. What is this? Solder tip storage R16. Yeah, I will just take some acetone and remove that because I don't like. I like it plain like that. All right, a cool thing. Wasn't cheap, I think. Let me check. The tweezers didn't arrive either. $6 also. Here. The what? Is Zichards zigzag. Zigzag. It's not Polish. Okay, I got it. What I'm doing, I'm reviewing the items that I ordered to improve my convenience. Courtesy of the what? Promote now. Shopping. All right, there's. Can I? Yeah, you can. Can I get a short URL? Anyways, yeah, you will find it. It's just an R16 functional soldering iron tip storage box. Nice. So this thing, also cool. You are most interested about the other stuff. Okay, this was cheap. This is something. I bought it because it's red, and red is my favorite color. If you didn't notice yet. And that's an actual PCB holder. Ooh, that feels really good. You can put like diagonal. I put it there. Chinese sweatshop. You can place PCBs like that. If you need like a corner, but yeah, this is plastic that won't fit. Let's put this one here. Yeah, either. Let me check if it's like holding. This seems to be like some fiber plastic, which is it feels quite heavy. So, but it's not. Yeah, it's anti-static. Oh, this is heavy. Unfortunately, we can't reach the magnets, the magnet things here. We could reach in there. Let me check if that would work. No, it's not magnetic. What? Stainless steel. PSA. ASA. What does that mean? ASA, is this like a type of... Anyways, yeah, not dicking around anymore. I guess. I don't know. I hope. They're different sizes, I guess. Is this like a different one? Yeah, it feels like it's gripping quite hefty. Yes. It's quite good. I like it. So this thing, gaming. I'm not gaming. This is a maker channel. We are making PCBs like that. We do some coding today and maybe PCB design. I have still to optimize. No. I'm not. I have. Okay, so for your updates, look at that beautiful connector here. Also, look at that. You can see multi-board design. Okay, so here, the first oh, I lost the view. Where is it? No! Here it is. I need to get, so this is a first preview of 2 of the 64 blade boards, and this is not properly aligned with the connector. Unfortunately, there are no like tools to do it properly, but this is what what did I do? What am I zooming here? I'm struggling with, with only like these are like 20,000 components already. Like the one board is it's like fractal. Yeah, I'm streaming with this PC, so and it's 20,000 components. So with 64 of those, it will be a lot. That's like, wait, it's like 500,000 components if it's fully populated. And it will be like completely a round trip here. This is the view of the board. Look at that. Look at the board. Look at the board. Let me put you here. This is a 3D view. Yeah. This is still working, but if some operations take really long. If I re-pour all the planes, it's a city. Pew 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 pew. Wait. Pew 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 pew. Okay, too flat. Here. TIE fighter. Wait, we have a tunnel here. Okay, the PCB, yeah, it's 6 layers, so that's quite pricey. I think the PCBs alone will cost me $1.2K, and the components, don't ask, like 10K if I like 5 Corporation City. So this is quite an extensive project. And what you see here, this is if you get, we got Altium on board for this project, and basically if they wouldn't help me, I would never build this. This is the size you can see here. This is half half of the row. This is basically exactly the same thing here. Just we've added the connector to the side here. So if you compare it here, you see that? The controller, half the row, that's like 16 and 16, so 32. And it's interesting, they're like, they're staggered, like this row is shifted, but only the MCUs, the LEDs are all centered. So if I turn that on, let me power it up. You will see the LEDs are all aligned. They're perfectly spaced. Oh yeah, we uploaded a different firmware there. But this is basically, yeah, we have like a perfect grid in the end. And this is just for the looks. But this is basically what you see on the screen. That's the 570, yeah. CH570. This is the CH32V303. And this is the 570. And on one of these blades are 1024, 4 of those, and we will have 64 blades hopefully at the end. So the first batch I can make like 8. I have all the components already stocked on JSC for all the LEDs for like 70,000 or 80,000 LEDs stocked. The MCUs, I got WCH sent me already 10K, and the crystals and the other ones. So I have enough stock for making 8 of the blades. So if let me load that blade. No, the comps are SPI and a combination of parallel bus and SPIs. Basically, yeah, it will be a cluster, a hierarchical cluster with. I want 1 MCU per pixel. I hope to have like an analog VGA in the end, also a connector, and 16-bit per color component. So this is better than RTX 5090. Yes, 570, 100 megahertz clock rate, and has multiplication bit operations, so fast FPU conversions. And yeah, the bit operations will help with probably with the the benchmark, but the multiplication is more important, like more on these ones compared to this cluster that I made before. This didn't have multiplication and didn't have bit operations like leading zero count, and these have leading zero count, and this here the 303 they have an FPU. So we have these are basically one of those is communicating to 32 of those, but on one board we have 32 of FPU capable MCUs. So in total we have 2000 MCUs with FPU. So even if the other would struggle, these here are already more than I have like on any other of my clusters. So these are like 160 MCUs without FPU, and like these two blades are already 64 MCUs with FPU, and these are $1 each if you buy them, like the CH32V303. Where is the blade base? I think is it updated? Yeah, look at that. Blade base. I think this is like a new update. So this is how the baseboard. We can do whatever we like, calculate stuff, render stuff, ray tracing, zigzag. Why don't you don't get it? So whatever you do in life, why don't you get it just finished, or why don't you buy it from someone who's better at it? The option is always there. We do stuff because we like to learn, we like to develop, we like to amaze, we like to be amazed, and I see the potential that this will be a piece of art also. This will be like not only the computational power, the power that it draws, like 3 kilowatts, also like 70,000 lumens of light. Yes. We need to, I don't know how to do it, but basically the communication is quite fast between the rows and the individual, like all the MCUs within the row. Yeah, I'm an artist. you didn't know. You're not new to the channel, so you should watch on my main channel. You should watch the videos. You know. I guess you're now main customer. So they sponsored 10,000 MCUs right now. Oh, I don't explain anything. Oh no! Only people who know everything. I mean, you can watch like the pocket bike. Watch my pocket bike. I don't explain it, but it's enjoyable to. Nah, leave zigzag alone. I welcome people. I mean, that's just curiosity and gaming channel. No, it's no gaming. Sorry. Wrong. This is a maker channel. So just escalated. This channel escalated over 12 years now. That's why we are here, and I'm not explaining stuff. The main channel at bitluni, you can watch like complete videos that are somewhat explaining stuff, but some are not. It's just documentation of the journey to build something, but not like very detailed. I mean, yeah, it would take hours probably to like the project. This one already took me 3 months, and it's still not finished. Like all the things that needs to be done. Installed. No, this is like very custom. You will be able to plug it in over USB to the PC and communicate with it over browser, and then upload code with RISC-V code or whatever and execute it. Or this is what I imagine we can do, and it is just like a fancy graphics card with J graphics. Roblox, yeah. Roblox for grown-ups. Anyways, will it run Doom? Yeah, that's you need to do the port then. But this is this board like took me so long to make, and it's still not finished wired. I just figured out the connections and the power. I have like specific power calculations on this here. Look at that. You don't know the level, this level yet. So these are like 4 levels. This is the lowest level. So each of the little MCUs, is it loading? Oh, it's so slow when I'm streaming. Here, this is the lowest level. lowest level. This is each of the individual small MCUs. Then we have repeat 32 times. This is the small MCU. This is the bigger MCU on the side of the board. And this is also repeated 16 times because we have like one column on the left, one column on the side. This is the column controller. If we look at here, this is one of the column controllers, and this is one column here. So we have a column controller that takes all the information here, the communication. Yeah, that's all right. Leave zigzag alone. Zigzag will enjoy it one day. Maybe get curious and wants to follow the journey, drops in now and then to see what the progress is. Yeah, do it, please. Zigzag, come back in every Wednesday. You can check in, just see what the progress is. Probably like in 2 weeks we might have the blade here and test it and run stuff on it. So that's what I hope to see. Maybe in 2 or 3 weeks it should be here. So this is the last level, which is basically left and right side. We have only 2 instances of that, and this is how the power distribution and communication looks like. ADC, yeah. Who does? I don't either. I don't understand what I'm doing as well. So no worries about that. A PCI Express connector here. This will be used for the blade, for the edge card. It's the typical. Let me switch to that. Yeah. So this is like a PCI Express times 1. This is PCI Express times 16. These are the actual connectors that will be used for the build. And Bloop. These are how the cards will be installed. But they are bigger. They are like 20 centimeters by 27 centimeters. So quite big. And these are the connectors, edge connectors. And this is also news for the people. It's not compatible with any PCI Express card. It's just the connector. And I'm using on the left side and the right side. We have SPI, shortest path basically for the SPI. And we have additional 16 lines. So we have 16 lines additionally to do whatever. Plus some extra lines, B1, 8, 10, 9, 11. So maybe we can even do like differential pairs or whatever with this extra stuff here. And 16, which can be written with one register. So we can do some parallel transfer here if SPI doesn't work properly or if it is not fast enough. Hey, also RAM available, you can calculate it. It's like 1 gigabytes or something distributed. If we use the 595, which is a different chip that I can get, we can calculate that. So we have 12K of SRAM. So 12 times this times this, it's 800 megabytes of RAM. But I have a different chip that doesn't require the clock, which has twice the RAM. So we have like 1.6 gigabytes of RAM distributed. But this is also for code on this one. If we gigabyte, 640K should be enough for everything. Yeah, we have a different option, but then I need to like DDR6. Nah, no, not doing RAM. Okay, but we are not finished with our stuff that we got shipped here. We wanted to try. This is for our testing of these things. bitluni gates, yeah. I didn't open them yet. So you recommended the power supplies. We will test them. Are they working? Are they good? Are they not good? What's happening? Ah, my tweezers. Ah. Ah. The 570 has like 12k apps. It comes with a... Whoa. It's an earthy smell. It's a weird smell. Needs to vent a little bit. Wait, is this the power supply? I thought, no, there's nothing in. This is the power supply? Are you kidding me? This is tiny. What? No way. Why do I have this pouch? You kidding me? This is it? Is this this is a power supply for ants. Why is the box so big? Oh, it's so cute. So cute. I look at my smile. It's not going away. This is cute. Look at that. Alien tag. Nice. Oh, yeah. Okay, I need to zoom. Enhance. New alien technology. Oh, wait. This is set. Voltage. 5 volts. What is current? Alien tech, yeah. Nice. Okay, so... Oh, reflection, sorry. Let me change the angle a little bit. Here we go. Whoop! That is also less reflection. That's cool, that's cool. Alright. You know what? Let's try powering it up because What cables do we have? Oh yeah, we have little clamps here. There are little clamps here. Okay, but I need to get 3.3 volts here. 3 volt in VSAT. Okay, oof. Okay, let's test the current limit now. Bloop. Okay, is it output? Is it on yet? On, off? How do you turn it off? Is it on already? No. Oh, constant voltage, constant current. And then let's try constant current. Wait, if I short it, here, 10 milliamps. That's cool. Okay, you know what? Let's use the old power supply here. And I think no, I mean old. What was the? Oh, I can't remember really. Where was? What was the ground here? I think this was ground and this was 3.3 volts. Yeah, 10 milliamps is not enough. Let's do 200, 300 milliamps, 500 milliamps. Yeah, it works. Yeah. Ah. Yeah, I need my wires that I ordered. Hate these things here. Okay, here. Cool. Nice power supply. That's tiny. Look at my hand. This is cool. I like it. That does exactly what I wanted for it. And I have a second one. Look at that. Oh, that looks nice. Look at that. Oh, this is cool. I drop your link. That's a winner so far. So far, it's a winner. Okay. The price of the PSU was... Where is it? Oh, wait. I think these are the shipped. No. Process... View all. Here. Should be there. More. It is $50. Yeah, it's substantial, let's say like that. What were the options? DP. What else do you get there? Oh yeah, an USB cable. A crappy power supply. What is the power supply? Yeah, you don't need all that other crap. Yeah, you don't need like a crappy power supply. Just buying the DP100 is good. Yeah. Here. Drop you the link. $50. It's passive. It has no fan. It's perfect. Love it. The only thing that I don't like it's not stackable like that. Try it again later. Oh no. Okay, I opened the second one now. We'll have a stack of PSUs, but I really need... Oh wait, we have like the rubber, the cable, the second one. This is so cute! Like you open the pouch, nothing in there. Why didn't they send like pouch half as big as that? Here we go. Smaller hand. Yeah, that's a PSU for Donald Trump. Here we go. Let's do fancy cable. I don't know if my power supply can handle like 2 power deliveries at the same time. Look at that, even with the fancy cable there. Yeah. It's wiggling around. Why is it wiggling like that? Okay. Oh! I can stack it if I look at that. So we have like these 2 rubbers. If I hook it like that, then it's stackable. Yes! It will probably fall over if you use 10 of those. Yeah, a 3D case like stackable, but this is already good. It looks like it's a little bit off, but that's only the shadow. That's cool. I like it. I like it. This is a winner. Thank you for the recommendation. I don't know who recommended it from you. but this is a good one. So far. Alright, here. One last thing that we received. That's the paste. I won't test it today. We just open it. The flux. Oh, that's very... Ooh. Thin tip. Nice. These are the thicker ones. These are like super thin. Yes! The titanium tweezers still need to arrive though. I hope next time... Oh, oh, this is... Okay, that's a massive amount though. That's some flux. Oh, that looks good. This is like crystal clear. I like that. And also, well, what does it look like? How do you put it? Is this sticking on there? Oh yes! Yeah. No residue, smoke-free, excellent liquidity, high weldability. Flux content. Here it says halogen content is 0%. Nice, I like it. I like it. Very, very nice tip here. This plastic thing. It's not screwed on, but it seems like it would work. So I'll leave the... I can't... Pizza. Oh, but it's sticky. Now I'm sticky. Flux sticky. Boop, ba-da. Okay, I will show it on the microscope. Microscope. Boop. Here. Very, very tiny. My tissues. Okay. So much trash. All right, so. Oh, for 2 resistor, yeah, you can dispense this flux quite precisely, like that. This will last me forever. Cool. I hope it doesn't dry, because I don't have a cap that fits right on that. How do I fit that on there? The resistor is probably 10K. Yeah. Cool thing. I hope we have the soldering irons next time. We can test a little bit more things. Love it. I love most of that stuff that we received. The only thing that I didn't like was the pink. The pink is not pink enough. The lights are a winner, I tell you that. Also, if the lights are really will free up some space. Hey DFGA, this is good. And the power supplies, love them. I have miniware load. Where is it? Do I have it here? It looks similar. It's a little bit bigger though. No, I don't have it here. I used it for... Oh, it's here. Yeah, I have it. But I tell you that the controls of the load, look at the load. Yeah, they will tip over if I put it on top of that. This is my load. It works with, how do you turn it on again? The controls, miniware controls are terrible. Whoever, no, that's not a PSU, it's a load. I think battery might be dead. Or I don't know how you turn it on. It's so stupid. You need like to hold two buttons to turn it on. Who made it? And yeah, of course it has a fan because that's a load. You need like to dissipate 100 watts. I think this one does 100 watts. Yeah, you need a fan. Yeah, so miniware, everything minified. Like how everything changes, huh? Compared to my huge power supply, this thing, like with power delivery, USB changed the world. I'm amazed. Yeah, DPU. Did you ever get a link I posted to the £10 alternative to work? What? £10 alternative? I got so many links, I have no clue. I bought these and they are doing their job, I guess. What I would like is a little bit more buttons, like one button for current. Oh yeah, here we go. Oh yeah, this one, yeah. Yeah, that's a basic power supply with a setting. Does it have current though? Can you set current and voltage? Voltage converter, doesn't say current. Bug boost. Precise voltage adjustment. Okay, yeah, that's a cheap alternative if you don't need a current limit. Yeah, in our first test EFGA was to short it to see if it limits the current, and that was like because I'm so terrible at doing things, I really need the current limit. Okay, let's turn it down, or let's turn it off. How do you lock? No. Oh, I guess I need to get used to the control A. I always... How do you... It's on, lock. Long press is lock. Pull the USB plug. No, I need to know. Ah, what did I do? Okay. How do... Oh! Let's turn off. Long press here, okay. That's version preset. Oh, you have presets? Wait. Oh, 10 presets. That's cool. Oh, no, I didn't break it. Okay, it doesn't come with an instruction manual, but this is like that's cool. I love the preset thing. I don't have that with my PSU, but wait. Okay, how did we turn it on? How do we turn it on, off? Okay, that does nothing. That changes the setting. Ah, here, right button. Just this one, okay. User interface. Yeah, I mean with 3 buttons. The encoder is that feels nice though. It's way better than this plasticky crap here. Store my face. This encoder is crap, I tell you that. Yeah, it not only looks cheap, like this is like this silvery plastic. This is not metal, this is plastic. And it feels like it wears down. I don't know who decided to use this. Everything else about this is like really high value. This is like metal case. Everything is good. Same like these. That it feels like very, very good. But the cheap OLED, I don't like that. This is like only. Let me turn it on for you. Turn that on. I think I need to recharge it. It has an internal battery. Yeah, look at that. What? CH? What? Which one has CH in it? Yeah, that the display is basically dated. I mean, that's like you could use the. And the user interface, look at that. You need like to have no clue how to. Yeah, you have to study. This is like even worse. I mean, to turn it on, you need to shut down. Okay, you need to hold these 2 buttons. Like, how do you find that out without? Okay, and then you have some settings. That's all right. Like, okay, let's see. Everything is peeping. Yeah, it's cool. I mean, I used it and it actually works if you like, but you need every time you use it, you need some time to basically get used to it again. Now it's charging now. It has an internal battery. Let me show you. I didn't know that. And it should be, yeah, look at that. It works even without. That's cool. I like that you can power it from the battery. This obviously doesn't have an internal battery and it's a power supply. We making stuff? What? Oh, wait a second. Here's an extra USB. I'm wondering. Let me grab. If you need an extra light, making stuff. Yeah, we are making stuff. I showed around the new project. Oh, yeah, it struggles. It struggles. The USB. Current limiting. Wait a second. But this is not controlled like like the output, or is it? Oh shit, no. Oh! Now it turned off. Okay. Do we control the USB now? We are setting up everything so it will be more convenient. Current limit. Yeah, no. This is not, probably has, I don't know why, 1 watt. It also shows 1 watt. Oh, this one is output. Yeah, no. The USB doesn't have anything to do with it, but it's weird that the light doesn't like that one. All right. I love the power supply. The green pan. Which green pan? Your green pan sucks. What? Big? Yeah, sorry. What? Alien Tech Power Supply software? Download the... What? What are you talking about? What? Controlled from the PC? Yeah, you're kidding. You're kidding me. This would be like an actual cool thing. Product information. Yes, it has. We used it already. We tested it and that's a product information file downloads. Product details. Mini size, multi input. Continuing adjust. Precise and reliable, high efficiency. Fully protected. Oh, I wanted to test what is the highest power I can go. Didn't you say like we can go quite high? Okay, so what is the voltage? Yeah, 12 volts. If we get 12 volts in, 12 volts is what we can get out. Yeah, it won't go. It's just a buck converter inside. It's not going above. Let me pull the plug here and see if we can get 20. 12. Yeah, 20. How do you go? Yeah, but what? How do you plug it in? I mean, do you power it then from your PC while using it? Yeah. Yeah, I don't know if I like it. Let me check. Yeah, my last actual. Okay, let me. Yeah, you probably, if you have. Okay, let me connect that. here. Boop. Okay, it turns on. Let's see if I can connect. Yeah, but this is the OBS internal thing. Where's my streaming window? Ramadan? Yeah, I'm doing some fasting as well. Not buying any sweets right now. Eating a lot of salad. Doing sports. I was swimming 1 kilometer today. But this is the first time I'm actually. It's not like it's fasting light. It's nothing religious. I just want to get fit again, because like back pain and everything, and I really sick of being exhausted all the time. So investing a little bit of time in sports pays off. I do just swimming and a little bit of like gymnastics. Ooh. Okay, let me download this software now, because I need the stupid link. Okay, yeah, I can copy the link from here. Here we go. Let me try that. Let's connect again. Nah. That didn't work. Okay. So let me try the software though. Ah, fool. File downloads. Did I miss something? Download on the right. Here. No. Yes, I experienced twice, but very light ones. Like power supply. The file download tab. There was a file download tab. Oh, here. Yeah, 5.5 maybe or something. It was weird. It was like... Okay. Oh. Ah! If you click on that... So stupid. If you click here... Okay. It was weird. Like, you feel really small. That was my feeling or my impression. You feel like you're basically screwed. Yeah. Cool. The power supplies are really cool. I like that they are thin. I can take it everywhere. It was like amazing. Cut on sugar intake. Yeah, this is sugar free. There's no sugar here. I have basically I don't eat sugar, anything that's containing sugar right now. Oh, I see. Look at that. That's USB A to USB A. That's interesting. I should have looked at this cable. So you're not powering. That was like, you can power it like that. We can connect it over USB A like that. Let me check that. If I can connect. USB-A. Oh yeah, I can hear that. Okay, so let's try the web thing. Yes, that works. So if you use the USB-A to USB-A cable, so okay. Yeah, it's only getting 5 volts, but yeah, you missed all the Quindo, you missed all the stuff, but we didn't get any of the soldering stations yet. Data out. What is, why is it so blinking like that? Status. Voltage in. Yeah, it's not getting enough power from the USB. Oh wait, I need to power it additionally. Okay, so let's get it. You can control it while it's, ooh, 5, wait, 5 point whatever. Let me turn that off. Oh, power supply is overwhelmed. Here we go. Yeah, I hate this power supply. It was good while now it's dated. Okay, we have 20 volts now. Let's get the USB-A. Ah, okay. So USB-A is for communication. Here we go. Data. What is this? Voltage. Output graph. Yeah. Oh yes, this is cool. Oh yes, I like it. Peeps, I like it. Ah. It doesn't accept higher precision. Nerd. Okay, status on. It's on, off. Ah, I hate this blinking. Why is it blinking? I don't like this data blinking here. Stop blinking already. Can we do 20? Nice. That's the highest we can go. The diode. There are 2 diodes in series. Nice. All right. I love it. Love it. Where's the here the power supply software, PC software. Oh, there is firmware as well. Okay, let me. Okay, PC software. Okay, let me disconnect that. Boop. Also, bye-bye. Yeah, I don't like the thing that I want. Where is the, what happened? I started and nothing worked, or what? .NET, FX. Oh, here. That was I installed. Here we go. Ooh, fancy. That looks like from case mod for a case modder here. Or PC aficionados. Yeah, here. Oops. Moved something here. Can I? Oh yeah, it can. I can change the size. Okay, UI doesn't scale. Anyways, on. Does it connect? Is it connected? Connect here. Here we go. Current version latest version 1.0. No! Look at that. Firmware update reminder. It wants me to downgrade. they just is it equal? If not, then let's downgrade everything. All right. So what do we? Is this output? Out mode off. Here we go. Let's do a current limit. Zero amps. It should drop when I touch it, because I have like my resistance isn't zero. It should drop. When I wait 20 volts, I can touch it with my tongue. Okay, wait. Can I do slide? Oh, 1 amp. No. Let's do 1 milliamp. Here. 1 milliamp. Did it change? Yes, it changed to 1 milliamp. Okay, let's. Where are my cables here? Here, cables. Let's short it and see what happens. Constant voltage. Yeah, 4. Output mode. Yeah, it automatically current limits here. Whoop. Whoop. Okay. Ow! Ow! Ah! My finger! Ah. I have a blood blister. Maybe that has a high iron content. Maybe I should measure across that. These clamps, they're slippery. Ah! Ow! Ow! They're very hefty. Ah! Ah! I can't pull it off. It's slippery. Ow. Oh. No, it's not drama. Look at that. Look at that. This. Oh. That was stupid. Yeah, why am I doing stuff like that? I like that. I love it. It's controllable. I like the clean interface. That's the clean interface from the software that you can just control it here. I like that. I don't like this part. Okay, let me just get rid of this row, and then everything is fixed. Here we go. Hexor! I'm a Hexor! This is all I ever wanted, all I ever needed. This. Can I connect him? I don't know. Probably not. It's probably not isolated. Hey, Ray. Okay. Oh, Wow. We spend so much time doing stuff like, but this is cool. USB A to USB A. But why didn't they do like two USB-C thingies? Yeah, maybe, yeah. I like it. Cool. USB-B. Like the chunky one, USB 3 B3 B3 B. Here we go. All right. Let's do some fiddling. No coding. Yeah. Or do you want coding or finishing that here? I should change the color of this component here. It should be more black. Okay, let's. So, what I'm pink. Yeah, pink. That was, you missed the part. Live, you missed the part. We bought this pink cable that turns out isn't very pinkish. It's not very pinkish. Okay, so let's do. I can turn that off. So what I'm, you know, to make it faster to refill my, if I refill the copper here, the polygons, that takes like, I don't know, several seconds, 20 seconds possibly. So I just did a new section here so I can check check if I got the grounds here. Yeah, this is, does it matter here? Ground, let me check, let me think about it. Now we have ground connected here. That doesn't matter. I could move that a little bit. Yeah, that will never. Does it? It does matter. You ass. Okay. Yeah, I have not much space there. I probably can move that down. And that. That might be too close. Wonky track. Which track is wonky? All the tracks are wonky. Why is it? Oh, wait. That worked already. Yeah. No, we want this ground to be... I think these tracks... Yeah. That view is cool. How do you like that view here? Like, you see where you can move around. Other things are, regarding the rules, blocked a little. Yeah, I would need to... Ah! Here we go. That's what I wanted. Yeah, there is no way we can fix the trace except for moving that over. Ah! Nah. Oh, that's even worse now. Okay, let's leave it like that. It's quite tight. Everything is tight here. I just want the grounds to be... Look at this mess here. Oh, wait, what? Oh, no, this is top layer. It doesn't matter. Just checking, so I have always my ground here. There is ground missing on... No, it's not. Actually, this ground... This is the topmost. I guess I need, on this side, I need some ground as well. So I'll probably move that down slightly. And place that one here. Yeah, that will work. So we have everything basically is wrapped in ground. Each data line. And what I'm currently doing is, look at that. These are like, this is the PCI Express connector. And I need to, all the traces that I made, all the traces here. Yeah, these here. I'm not sure about the order though. Might change that. Main part of stream. Yeah. You can grab your tea and the cookie, but probably no cookie at this time of day anymore. And what I'm doing, the first thing I'm doing right now, I rearranged everything basically today here. So I have basically yes, this is done. So the question was the question, Quindor, this is one of the best feature, impedance matching for that. So layer stack manager, here we go. There was one person who was nice enough to basically to transfer all the stack ups from JLC. So I have like this specific, I think 30 or something, I don't know. It's a specific stack up that I'm using. So it has like the distance or the thickness between the layers is very specific. And then you have this button here, impedance. And then what you have, basically you can create a profile. What is it? Target impedance. Wait, single coplanar. You can do like that. Wait, what was it? Impedance profile. Let me do dielectric. How do I do it? That's not that one. D90? No. Differential SC. So with coplanar, there is like where do I take? It's some time that I changed that. What did I do? There is like one setting that you need to do for a strip line. For strip line impedance with yeah, you need like to, so basically what you create there, I can show you that in, oh yeah, Fu made a plugin for downloading footprints in KiCad. Try that. Here we go. If you go to design and rules, basically, you have routing. So basically everything is based on the DRC rules. And you have like different settings that you can add. And I have like something for power, I have something for signal. And for signal, this is my profile, and it sets basically, when I select this profile, it selects like the perfect impedance matched width for each layer. So top layer is 0.127, like second layer would be like 0.1, and the center layer 0.11. And whenever I trace something, so if you compare the track with, so this is the top layer, We can measure even here. Let's try. It automatically, like, you can see that, and this width is basically different. Yeah, 1.1, 0.11, and this is 0.25. And when you draw the traces, I can show that. So here, let's say I'm drawing. I start with the thicker automatically, like with the impedance match rule. Then I change us with plus minus. I change the layer, only the visible layers, and it automatically changes the width of the track. So now I'm basically continuing with the, and this is amazingly simple now. Oh wow, this is like while streaming, it's quite slow right now. But it's also quite, what is going on? Yeah, this is, I mean, it's quite hard if you have like to, if you're switching. Yeah, that is one thing. It's quite convenient. I guess someone could write a plugin, but I think it might be really complicated. If you can have like, there is no interface basically to have different values, track widths per layer. So this is missing. In that manner, Altium is like way overpowered. Yeah. It's at some point it might come like it. Discord server. Someone will drop it. My scheme is to have them on each different layers here. I'm not like, I mean, I'm using Altium for 2 months, so I'm more proficient in what happened here though. Right. This is not, I guess this is, yeah, this is the wrong net. Let me grab the net here. Nah, this is the wrong layer. Okay, here we go. Yeah, that was the wrong, because I think I have, wait, VDD MCU2. No, that's all right. Yeah, that's all right. I switched the resistors here. I have different settings. Okay, it's retracing. Like that, I might need to move it over though, because this is still within the footprint and the JC might complain. Not sure about that. One thing that I like that Kaiket should also copy. Look at that. When I try to move this wire here, yeah, I can move it like that. You know it. Okay, yeah, this is, we are too close to that, but let me revert that. We can just move it. Let me take another one where there are no vias in the way. Okay, so I can move it like that, but quite often I want like to add a kink here, so like a knee or whatever. So look at that. There is like a center thing, and if you use that, ta-da! This is underrated feature. This is underrated. Sometimes in the beginning I was annoyed because I used it accidentally and then it didn't move like the whole thing. But if you like, this is I guess this is easy to implement. Like if KiKit could just copy that, amazing. Sometimes you want like to move your wires away or whatever. Let's say I would go, okay, maybe go around like here. This would be a good example. I want to free up some space left from that, so I would just take that, and here we go. This is done. With KiCad, let's say with KiCad I would need like to move like that, and then move it back, and then move it back like that, and then here we go. Yeah. So there are a few things that I really like. Oh wait, I missed that one. Foo. Yeah. Oh, this software doesn't behave well while streaming. It's already like so overwhelmed with the size, pure size of the board. Look, whenever I touch something here, what the stats? What are the stats? Tools. Where are the stats? I want to know how many traces these are already. Reports. TTS interruption, what? Measure primitives. What is... No, this is not a tool. Reports. Board information. Okay, let's see. Copper area. No, there's... I don't know how to... No, but board specifications, layer information, all on here. Let's get a report. Let's see what's inside, what's in the report right now. Sometimes it gets really slow when I report. I removed like the tracks, 100,000 tracks. Routing completion 99.2%. Inner layer, okay, top layer. That's the top layer alone. Pads 41,000. The free version of DipTrace would already shut down. They have to switch the tool several times. Where did you find the vias? Where's the via count? I didn't take the smallest via diameter because I know like there will be errors in this board if they try to drill it like with the 0.1 millimeter drill. Wait, where is the connections? 27,000 connections. Connections remaining 220. They have still to be routed by hand here. We could use auto-route, but I don't trust it. Yes, they're probably taking another day. Yeah, sometimes. Yeah, I'm practicing. Sometimes when TTS, like we have a lot of people, then I'm basically blocked by TTS. I have to process everything. I practiced ignoring you just. Yeah. What is this? Not a number. A copper area. Total, not a number. No. Layer 1 and 5. Where's 5? Wait, no. 1 and 4 are um, ground planes. They are really needed for the signal integrity. I pay really much just for that 2 layers to be there. We need a non-interrupted ground plane to have basically not all the crosstalk and no the noise like put away. Board holes 20 26. Yeah, I know. This is I pay extra. I know it, but this is like just for testing, and this is a trade-off. I didn't take the smallest VS, but I took small VS because otherwise the board would be bigger, and I need to fit into a confined space. Annular ring size, yeah, that's very challenging. The stats are crazy. Track width. Here, track width. These are basically non-signal tracks. These are the LED tracks and the programming pin tracks. I left them at 0.1 millimeters. The smallest would be 0.09 for JLC PCB, but I didn't want like to total trace length. We can check text track with how many kilometers you think? Does it say anywhere? 15 kilometers? No. I don't think it should be that much. It's probably like maybe it's below 1 kilometer. 1 kilometer is a long way. Most of the traces are can see. It's below 1 kilometer. No, I can't search this. I don't see the length anywhere. Here, no, that's length. Max expansion track width. Doesn't say. Sad. Anyways. Yeah. Nice report though. Nice report, dude. Via copper mines, yeah. One copper mine is our power supply, 3 kilowatt power supply, and that's a copper line here. Oh, look at that. Oh, I pressed it saved the board. Oh yeah, wait. Need to turn off the component selection. It's a little bit more convenient than the checkboxes at KiCad. Like here, the stuff here, the configuration, how you select stuff. Okay, let's do that. And do shit. Oh wait. How many? What? 41 meters? Uh-oh. Okay, I need to switch this to, oops, here already. These should go to this layer. No, wait. Yeah. This is the layer. This is inner 2. And this will be I need to fix that here. Responsiveness. This. We have some space here. We have plenty of space up there, so I will just move all that stuff up here. Boop. Oh, one cool thing. As you can define so many grids. Look, I will show you how many grids I have defined. You can basically have a different grid for here. These are all my grids here. I have 11 grids defined. And you can basically say this grid is for components, this grid is for traces, whatever. And then you have like a range or a like coordinate where the grid should start and stop and everything, where the origin of the grid is. It's really cool. And there are polar grids as well. Show you that here. This is a polar grid. Look at that. Ooh. Yeah. This is basically, I mean, how often do you need that? Not very often, probably. But man, this is cool. Yeah, I'm using quite a lot of grids. Especially like I have look at that, like my traces are all staggered, and I have defined basically a grid for the vertical traces. I have okay, the horizontal as well, like the buses. Then I have a grid per core. So let me show that. So I can basically copy a design and then just move it exactly one step to the left or to the right. That works also with the core grid, half core bus with vias. Okay. Core grid left. Yeah, if I use that for components, let me turn the other ones off. Here, does it show it? Left, right? Not sure if it, yeah, you can see it here. Here, there's like this grid. So a rough grid for moving stuff. Then these are vertical guides. Vertical and horizontal guides, so you can add lines, which yeah, it's very fancy. Okay, enough talking here. let's do some work. More worky, less talky. Sure if this is good here. I need to add some grounds, and these shouldn't overlap. Okay, maybe this is premature here, but I need the ground there. So I try to add basically, since let me show that. I probably, it's a long time I explained that maybe. So let's see. These are the two inner layers. And if you look at that, let me refill. If you look at that, yeah, this is, I'll fix that. So basically, this is something that I need to fix. I have like, this is like strip line. I have on this layer, there's always copper in between. And then I have like a different trace. There's always also copper in between. And these two are basically the inner layer that are sandwiched between the ground planes. And if everything is done, they are staggered like that. So basically this green one here, is it green? Yeah, I hope it's green. It's always on top of a ground. So it's sandwiched between ground here as well as this one, this cyan it's wait, here is also sandwiched between grounds. So green, yeah. So we have like, it doesn't matter. It's always all the GNDs on top, on bottom, left, and right are closer than the next trace. Yeah, it is. It is, but there is no signal that is closer to the trace than. Yeah, it will couple to this ground then. 0.1 millimeters. So probably it doesn't matter, but I just want it to be completely enclosed with grounds. It's probably completely overdone. It's completely overdone, most probably, but I wanted it like that to have like the highest possible integrity. So this one needs to move a little. So we have that here. This is also, but I guess I should swap. No, I can't do. I can swap that. Yeah, it's like everything should be wrapped and ground everywhere. That kink, I don't like that. Yeah, no matter what, like the next signal is basically a diagonal, and on the left, on the top, on the bottom is always ground, which is closer. So on all sides we have, and the next signal is basically diagonally and shielded by the ground. Yeah, so let's fix that. I will move that. Yeah, we have enough space here. Let's move it over here. Let's move it over here. Let's add the ground via here and there. It's probably boop. Yeah, especially inside the board. If you consider that we will have, look at that. These are like, we have 65,000 crystals here swinging around, and basically they're like, this is only on in the center of this configuration. They're only like millimeters apart. Here, the board. Okay. Test bed, yeah. Test bed is like, look at that. Okay, in this case, it's touching, but no, this won't pass anything. This is like 3 kilowatts of 32 megahertz noise. I hope that we have at least like some drift, that we have like, it shouldn't synchronize. Like the center will be way more warm than the outer part. So there will be a drift in 32 megahertz. What? Custom exception for bitluni, yeah. No, this will be something, I tell you that. It's a crazy thing. Spread spectrum. What is this? Yeah, let's move them around, squeeze them a little bit closer here. This ground should be fine. Yeah, let's get it closer. Yeah, I know. Okay, this is too close. There's one thing that I'm missing. Is like to show basically the hole to copper distance. Yeah, now it will be. Yeah, so I hope the PWM, the LED PWM won't be an issue in the end. I guess this will be more trouble because we have plenty of, look at that, these they're like also 65,000 LEDs, which are here, and traces to the LEDs, which are all, what is the frequency? The frequency will be 100 megahertz divided by, I think it might be half of that. 60. Yeah, it's probably half of that because PWM, that it doesn't work like full. Yeah, 760 hertz noise, bulk capacitance, no space. Yeah, I don't have that. The issue is if I have like bulk capacitance here, then the power supply might be just like, you have like a current in rush. We have this basically the a little bit of capacitance with the thousands of 100 nanofarad caps. Everything beside that will be handled on the main board. I don't want like to have, I can place capacitors here. I have enough space close to the connector. So I will put fuses here, like a resettable fuse through the power lines. So if we have like an inrush of current over 1 amp, it might turn off or whatever. Not sure yet. But if I put like caps on here, then I have to rework it if it's overwhelming the power supply. Yeah, but what's the difference if I put them on this board here instead? Here, I mean, there. No, I won't place them by hand. This will be manufactured, and you know what? I'm really struggling with the idea to like. Yeah, it has enough pins. I calculated the current per pin for the LED power. It is 400 maximum, 400 milliamps. For the MCU, it's 320 or something milliamps per pin, which is all right. There are 4 amps. Yeah. No, I guess I will handle it there. Otherwise, I will scratch off the solder mask and put like caps on here or yeah, we can fix it here at the PSU. I hope the PSU has enough SMD pad. It's free. It's not free because it's extra work for me. Isn't really free if it takes me even longer. Like this project is taking too long already. Yeah, this squeezing everything. By the way, I turned off the automatic refill of the. This will just be here, the key codes. That looks alright. That looks alright. We have that figured out. We can move these closer. This is. Yeah, I know. And I knew it. I knew that this project will take a long time, but it's not my first rodeo. And probably my last big one that I do myself. I mean, what if that ultra cluster turns out well, I hope that it gains some attention in the press. And if I ever want to build something bigger, then I will just hire someone of you to do the design and iterate through, and I will just try to manage everything else, because that's like doing everything on my own is I should move past that. Even though, I mean, it's a part of the entertainment. The ultra cluster will, yeah, the AI that we run on it will design. There is a king here. It will do it by itself. Why is just a little bit overlap? We don't need. I don't know why I'm squeezing it. We have enough. We have plenty of room. I don't think we need like. Okay, we can put some of the traces below the connector here. Like that. Foo. Here, look at that. We have so much space here. Perfect. Nice. I could even move closer. Why am I moving away from that? This is like exposed. I think the die is like here. Die shouldn't be that big. So there is not much noise going on. Wondering if I can move it closer though. I need the space. I don't want to squeeze if it's not necessary. Yeah, I'll leave it. This is probably too close already. That will flag me in the DRC check, because this is like approximated, as you can see. That's a polygon. All right, here we go. I think this is the radius. We match that. Move it closer. Here. I like to do some work here. You can talk to me. I'm listening. Did you get your tickets for Project Hail Mary already? Oh, I should get mine for the cinema. I successfully dodged all the trailers, but I mean, I know the book, so it should be coming like in 2 weeks. Anything else interesting in cinema? SMRRF, what is that? Short for what? Oh, Jody, yeah, your seminar or what it was. Remember. You're looking forward to it. You're talking about that for weeks already. This is like, you like the trips, huh? Look at that, we have so much space here. Nice, let's give it a ground pad here. Boop. Via. That's cool. I'm happy for you. Oh, I have news. Peeps, I have news. Stream next week might be delayed because I'm going to Embedded World on Wednesday, the 11th. So if you are going to Embedded World, Sonic, maybe uh, you're coming. I mean, uh, anyone who's there anyways, you should poke me on Discord and we can exchange. Oh shit! There is nothing. I need to refill first. Exchange contacts, and basically I will already probably meet like 2 people that are unfortunate. But Jody, okay, you said you. I booked my train. I will arrive 9:45 at Messe Nürnberg. So I'll be there from that time. I'm meeting Stuart, who is a really cool dude I met at Hacker Day Europe once. He Oh, what? Oh, light plus building fair. All right. I mean, that's you're probably selling a lot to these people, huh? Do you have like a booth, or are you just contacting distributors, like networking? Yeah, it's probably nice to get like, hey, ITT. So I be probably. Oh no, light. I might be. Your audience is like that, but embedded world. I sometimes meet people, so that's cool. Oh, look at that. We squeezed too much. Let me move that a little bit further down. We have still some space here. Yeah, here. Oh. But I don't know what to do there. I really don't need sponsors anymore. So um, I um, I I just want to meet a few cool people. Like Stuart is basically he works with Matt Van, Tiny Tape Out, Matt Van, and he basically manages stuff in China. So he's also like I think he's an engineer. Um, there is a I think he even did a short talk or at what is 2 years ago. Radio station, Quinn controllers, what? Um, and what I need like someone who's really who has the connections in China to basically start manufacturing. I mean, Quindor, you have the connections probably as well. And Dutch Maker is also quite present in China. But Stuart, I need like someone who can manage stuff there if I want to manufacture anything. And I mean, I have a brand, but I don't utilize it for selling anything or I don't know, licensing with my brand. And I should really do that because many people like the VGA stuff or like all the display interface stuff that I did in the past. And there are quite a lot of, let's say, products that use that, but it's not my product. I give some support, not all the support, because like I'm terrible at giving support. But I should basically outsource that, and I want to provide like mini clusters like that, so people can tinker around. This will be, and this one is like 6-layer, but if I do 4-layer version of a cluster like that, that would be like $20. And I want someone to handling everything, including like distribution on AliExpress. And I want AliExpress specifically because I like to buy stuff on AliExpress, and I want other people to link it, and I want whatever. I want the best convenience. I don't want like my own shop, whatever. I just want the stuff to be managed there. Shit. I've done it here. News about components delivery. Oh, ITT. Which components do you mean? You missed all the parts. We received some stuff which is cool. We didn't get all the soldering stations, but plenty of things like lights and everything. The components here. The components here. Or which components do you mean? Yeah, I know. Triple the price, basically. Triple the manufacturing cost. I did. That's all right. That's all right. Just for the convenience, it's worth to pay. You don't really want to manage your own shop. It's overhead. I don't want any overhead, basically. So I sold PCBs before, and I made basically the experience with manufacturing cost, like triple that for the selling price, because you have always broken things getting lost and whatever. And if someone can manage that, also the production. I mean, I used Maker Fabs for that in the past, which was cool. Probably Seed Studio is also nice because they have warehouses everywhere. But yeah, I need like people in China to handle like AliExpress or whatever. I don't know if I think Maker Fabs doesn't handle AliExpress. That was one thing that and I want Ali. So I don't know why is this. I don't like this. There's so much wasted space. If I move that down. Yeah. Right. Let's move it like that. Oh yeah, for sure. I mean, I have the price. What did you say? Oh yes, you said sorry. You said that you don't go to the Maker Fair. I booked my hotel for the Maker Fair. I'm coming. Coming Friday, Hanover. Coming Friday, leaving on Sunday. So, this year, yes, I'm coming to Maker Fair this year in Hanover. I booked my hotel yesterday. It's still cheap, like $70 per night. You, Johnny! Okay. Yes, local sellers some cheaper. Congress Hotel. Yes, I booked Congress Hotel, It's quite cheap right now, so I don't think it will get cheaper. And if this ultra cluster works, this size, I will take it with me, and that will be the only thing that I will take with me, probably. And I will place it on someone else's booth. I don't want like to take care of it, but I will place it there and leave it there, and it will entertain people. But this is probably, if this ever works, this will be the chance to see it in action, live, at the Maker Fair. I don't know if I ever will take it anywhere else. Yeah, probably. Yeah, probably. Yeah, but I don't like to bother my friends, so I probably find someone else like make local resellers. Oh yeah, so by the way, I have like if you order at LCSC, let's say the CH what was it? Let me pull up the quotes. I don't. I mean, it's something. I don't know if I can share every detail, but let me hide that. I don't want to spoil anything here. Okay, so I got a quote. Let's compare it. 1.13 RMB for the okay, so here Chinese yuan. Okay, this is the quote that I get for the CH 572, so the Bluetooth version, 12 euro cents. And now let's pull up JLC parts. It's similar, I think. Like if you go, I mean, we can also go LCSC, because the 70 CH 572 is here 72D 18 euro cents. If you buy, oh yeah, let's go more, the full reel, 1000 plus, yeah, 18 cents if you get it of LCSC. And I think the last quote that I got from them was like $20 cents, which is similar price. So the price difference is substantial here. That's like 50%. 50% up mark if you try to get it. I mean, they do probably like taxes, whatever. This is if I get it in China, for China. Oh yeah, that part. Oh yes. Oh yes. Oh yes. Okay. That's a cool story. That's a JLC parts. Oh, ITT. You're yeah. Your last update. Your update on. Let me sign in. I show you something. That was a cool story. So. Let me go to my parts manager. Here we go. Boop, boop, boop. 119,000 parts. Do you see that? Whoop! Yeah, can I zoom in? Here. Okay, so obviously, shoot. Hotel booked? Nice. Look at that! Yes! Yes! CH570D! Cosine part! It worked! But the funny thing is, so if you cosine stuff, okay, I can't. Can I click audit result? No, I can't do this. If you cosine it, they want a price per piece that you paid. They want the invoice, and you are not able, like, the shipping number and everything, and you have like the CC number or something that I wasn't able, like, you have to put it on the parts or whatever, and I let them basically ship to the Chinese address WCH. They shipped it, and then I had like to handle this stuff, and I don't have an invoice because it's samples. Like, I got a sample of 10,000 parts here. WCH, thank you very much. This first batch of this will be 8 blades only, peeps. That's only enough for 8 blades of 64. That's 2 full reels. Yeah, amazing. So Patrick, thank you very much for providing this, and I hope we can make it work. I hope we can make it work. Anyways, the interesting part is you need to upload an invoice, and I didn't have an invoice, and I chatted with the support. That wasn't very helpful. So you know what I did? Maybe I can. I still have it? What I uploaded instead? I uploaded a zip file. Where is it? Here. I uploaded a zip file with three documents where I just stored, like, as a PDF. I printed the 2 emails, the one email with the quote for the part value. I don't know, probably they need it later. $1. Yeah, but you know, the communication is so, that would be like 2 days of communication. It's hard, like, to communicate if the other side is only talking, like, I mean, they use translate, but it's quite hard, and they sent already the chips, and then you need, like, can I have an invoice, whatever. And so basically I have like I don't want, like, to open this, but this is basically a printout of the email that shows the pricing, like, for the parts, and this email basically where they state that they sent me a sample of 10,000, and then this note here. Oh, did you see it? Okay. This shipment is a free sample, and there is no invoice. Find attached the email communication proof of the parts being sent as sample and the quote for the actual price. This is all I added, and it worked. It took them only 2 days to review that. All worked. Yes. Amazing. And they are waiting. They're waiting. That's why we're trying to finish that. And then let's hope, like, I need to counter check the DRC rules 5,000 times. The last time I ran DRC rules checks was like hundreds of errors, but we have, like, tools. So you know what happened? I show you what happened. So when this is like an array of these are 1,000. This circuit here is repeated 1,000 times, and if you copy the traces in the vias, then they will be there like free objects, and if they touch a part, like we had like, let's say the chip with the nets, then the nets will be attached. Cell processor from Terminator. Yeah, it's more than that. Look at that. Yeah, it's more than the cell processor. So basically, it attaches the nets that the copied traces are touching. And the issue is, I have 6 layers, and I had like copper pores on each of the layers, and 2 of those are grounds, and I didn't deactivate them. So one pro tip: shelve all your copper pores. Shelving means you put them away for later. They're still there, but they're not active. So if the traces are copied, then not whatever the via is touching is dominating, but the pins. And my issue was, I had all the traces, all these here, not all of them, but 10% of those traces were wrong net. It was ground, not VDD, MCU, VDD, MCU 0. So I started to, I had like hundreds of DRC errors. So I used that, pressed tab to mark them all. And then you can basically use a color picker and pick this net to reassign the nets. And I did that and repeated and repeated and repeated. And you see, for each part of this trace, you get a separate DRC rule error. So thousands of errors. Yeah. So and the issue with that, I thought, yeah, okay, I will just fix the 10% that went wrong. So that was like, I don't know why it was like really random. So most of the traces were right, but some of them were wrong. And I thought, oh, well, yeah, I will fix them. But then I started to fix, and it took me like, it takes 10 seconds to fix one trace, but there are 100. So you're sitting here for like an hour just fixing, doing the same thing over and over again, and then missing some of them and whatever. If you zoom out, you see, okay, like if 10% here, that's a lot. And look at how small this trace is. And there are like 100 traces that are wrong. And there is a tool actually that does the job for you, just one click. So ignore it. Yeah. Then you will have shorts, because look at that. This is VCC and ground that was like attached to ground, and VCC and ground, that doesn't match. So either, I don't know what would happen. It might be possible that it would have shorts, like the complete board would go wrong, or they will be just supplied with ground only. So that was an issue, and there were like different traces. This is only one of the examples that went wrong. Yeah, my amount of microcontrollers is absurd. It's like noise. The compression, I don't want to see like the compression on YouTube. So what does the compression on YouTube say right now? Are we dropping to 260p right now? All right. Terrible. Yeah. Magic eye pixel. Yeah. If you look like that, you can see a 3D object. It's 30p. Yeah. Yeah, basically. A Moray effect. You can see a Moray effect. All right. So, there you see it. I thought. Basil, you're hilarious. All right, so what I did, I shelved all the ground planes, or the polygons. In that case, they are called polygons here. I shelved them, and then you have tools. Yes. Here, netlists, update free primitives. You click that, everything is reattached to the pins that are provided there. And if the planes are gone, there is no ground. And everything is right in the end. This was like 2 clicks, everything fixed. I don't have like to click around for 1 hour. Woo! This is like a step up from being a noob in this in Altium to like intermediate user. H265, yeah. AV1, really? I think I'm using H265 right now. I can't go in the settings. Let me check if I can open the settings. Stream. Yeah, I'm not showing you my stream key. Output. No! Oh, really? Oh, interesting. I think the last time I did my settings. Oh. Ugh. On Twitch. It's AVC on Twitch. Okay. Yeah, this is. I really want a short latency. I don't know if that changed. I have ultra low latency. That's why I'm on HD. For what? Yeah, I have the ultra low latency, so I can. You know how terrible it is if you can like if you have like. Oh, look at that. Yeah, I have like simultaneous upload on Twitch, so I need to split it. I have a total of 40 megabits upload only because Germany. Unfortunately, I'm waiting for my fiber for 2 years, 2.5 years already. Oh, 2.5 seconds. All right, so I mean, my screen is 4K. I would totally stream in 4K. That would be enough. Oh. Oh. Okay, 30 FPS would be enough. I could stream in 4K 30. 2015. Why is this? Wait, what? That doesn't look right. That's new. That's. Oh, AV1. Something's wrong. This is like new. This is new data. The last time I checked, they recommended 6 megabits per second for 2. But this is wrong. Yeah, my bitrate is too low. HVAC AV1. Okay. Yeah, I will try next time. Okay. Ultra low latency. What is the not available? All streams we optimize quality. Okay, so we can't do like the lowest latency. GTX 360. That should be all right. It's not busy right now. Let me check. And it does like, I don't think it is. I don't know if it's transcoding 2 times. Yes, yes, yeah, that's what I mean. That should be all right. Let me check for what OBS is doing regarding GPU. Oh yeah, okay, 50% usage. Why? Is it bad? It's using 14 megabits per second. Look at that. Because I'm streaming, like I'm doing 2 streams. I'm not sure if it's transcoding 2 times. Graph section. Where do I? ITT. I envy you. Symmetrical 600 megabits. Leistung. Here we go. Oh, it's struggling to just switch. We are only using 84 gigabytes of RAM. Wait, GPU, video decode, video encode. Yeah, no, it's quite busy with encoding. Altium? No, it's the browsers, I believe. I'm not sure. It's not Altium. Is it Altium? No, it shouldn't be. Oh, whoa, look at that. Task Manager is. No, it's. Yeah. Altium is only using 5 gigabytes of RAM. I don't know where the RAM is gone. Yeah. Yeah, for 128 gigs of RAM. I have no clue where it's going. Let me. Yeah, look at that. I think this is cache. Oh yeah. Basically that's cache. So the actual usage is 30 gigabytes. The rest is used for cache. And that's what I want. I don't want a swap file. I don't want the SSD to be running all the time. I just want this here. I want it to be all used like that. That's in standby. Look at that. 32 gigs are just standby. And what's this? Free. 11 gigs. Yeah, so 30 gigs. I guess 64 gigabytes of RAM is enough for everything. I never saw more usage than that. Even with video editing, and I basically, what I want is like the large files. Yeah, that's a bottleneck. My CPU, specifically the single core performance is quite busy. In Altium, the single core performance of my CPU is the bottleneck. And yeah, unfortunately, I don't have a. It's a little bit dated. Oh, CPU process. Logical cores. Yeah. These are the physical ones. Yeah, these are physicals. Physical cores. Guess, wait. Oh, bye, Basil. Yeah, I don't have hyperthreading, I believe. I might have hyperthreading. I don't know. Threads, handles? Yeah. 8 core and 8 logical cores. Yeah, this is streaming and everything. What is taking so much CPU? Oh, oh, Fu is. Oh, right. Okay. Fu! Good night! I missed that! Fu! Yeah, 10%. It's just because I have so much stuff going on. Probably also. Oh, yes. Oh, bastard Slack. Yeah, this is the commit. Let me close that. Let me close. This is my. We are communicating. We are using that for communication on. Now everything is really. Oh, I don't know why Slack is so terrible. Oh yeah. Oh, 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 oh. JavaScript, but why is it like constantly using it? It's not even in the foreground. Even if you close the window, it's like mining. It's mining crypto coins. Look at that. All of a sudden, I can work here now. Electron. Yeah. Yeah. Spin lock. Oh, it was always Slack. Damn it. Ah. All right, so let's do some wiring here. Oh, we have more traces here. Let's see. Bitrate. What did it went down? Yeah, did it go down? Sorry. Double. Ooh. Yeah, nah. It's not much. I don't feel a lot of difference though. Let me fix that kink. Some weirdness like doing the trace is similar in KiCad compared to KiCad Plus. Guess this. Okay, and this. I have still a few pins that I didn't use. Oh wait. I want it here. Yeah, look at that. Oof. Yeah, still struggling. Still struggling. Auto routing. What did it do? No. I was trying to find a route between all the 1000 cores. Yeah, it's not much faster anyways. Will it work today? I hope. I don't know. I need to order it very soon. Let me do the traces here. Is it ground here? Yeah. You know what? I'm so scared. If I imagine I order 8 boards and none of them work. Like I want some. This is the last quest for JLC. ITT, you're probably interested in the if I can manage that to let them only populate one board, keep the boards, keep the stencil or make a new stencil, I don't care, but make 8 boards or 9 boards or whatever, populate one ship it to me, or make 9 boards, populate one board, ship to me 1 populated board, 1 unpopulated board, so I can find out whatever is going on there. Maximum CPU. Oh, how do you do that? ITT. How do you do that? I want that. Oh, I had almost a brain fart. I wanted to move the cap over here. Yeah, but the live, the issue is I want. Oh, PCBA is still on holiday, so ooh, it's not my problem to, like, it's not I'm not the issue still. Okay, yeah. That's good news for me, because I thought I'm delaying the project, but it's JC still. Yeah, okay, I have a lot of traces here. This cap, yeah, Electron apps. We should ask Electron Ash. What happened to Electron Ash? Didn't see him in a while. What's going on here? Here. Rest easy, update 3 traces. Okay, maybe I should, you know what? This is PA3. Probably, I don't know, or they did something else. I'm wondering, how do I swap it? Because this is 3, C8, A1, A2. Yeah, I want to keep the order, so I will just move it down. Like that. It's interesting, huh? Move it down like that, and then I will trace those here. But this is, oh yeah, components. No, never shift the components. What? Wire this plus. So how do I convince JLC to basically stash more boards? Because the boards are very expensive. The PCBs themselves are very expensive to make, and I just want to make 1 batch of PCBs for now, but only populate as few boards as possible, because for testing, because the parts are so expensive. So if I mess up the board, then they can basically trash the rest of the PCBs, and I didn't lose 10,000 parts. That's my problem. That's what I want to figure out with, if it's possible. It will be a hard communication, but it should be somehow possible. I mean, they're keeping stuff for me, 10,000 cosine parts. Really? Yeah, probably. Live support. Yes. I figured out many things with the live support. Oh, look at that. Woohoo! New feature. Bam. I will try to figure that out with the live support. Probably is best during the working hours. I have mixed experience. Sometimes I get the same responses. Okay, let me do that. I hope the order is right. Not that I have like to swap it again. Oh no, wait. I should reverse the order here. Because that's incrementing from here. A5, A1, A2. Oh no. Yeah, no. This is stupid. I need to reverse it. No. Oh, you mean... Okay, yeah. That would be a thing. Just to order... Then I have like the overhead because the setup costs and testing costs for the PCB are around like $100. I'm willing to take this up mark to only make one board. Bye, Jody. So maybe I should do it like that. You can order 3 boards. It's the least amount, I believe. And populate our min quantity is really... They can't drill. Yeah, I have a contract with them. They would sponsor it, but I can't put Altium and JLC in the same video. This is... I really don't want to do that. Yes, yeah, but then I have to throw away the other boards. Wasn't order like 2, 3 boards? Let me check that. How do they drill 0.1 millimeter holes like 3 millimeters deep or something? Okay, peeps, let's find out. Let's find out. Yeah, I will check with them. Add some... Oh, please. Don't order now. Okay, let's check. Layers. 6 layer boards. Quantity. Custom quantity 1. Must be a multiple of 50. Custom quantity can be... Oh, shoot. Yeah, no, I checked. Here 6 layers seems to be minimum. That's... If you specify like epoxy filled capped 6 layer boards, then we have this as an up mark. Then we have outline tolerance. I'm not sure if I need that though. And the width is... The problem is the board is quite substantially large. This is 27... Wait, what? Why is it only 170? Okay. Then it's not a problem. But no, yeah, I need to stack up. Wait. Where's the... where is it? Specify stack up, confirm. This is the one. Okay. That's the dimension. Oh? Why is it only $107? It can't be true. Something's wrong here. I missed something. Oh yeah, I want purple. Okay, 130. Because you know what? If you check what the capabilities, black can't be done with this precision. Only green and purple are precise enough. So I will take purple. That's why my preview in Altium is also purple here. Look at that. Here. I made it purple. I love the purple color. I made other purple bots before. It probably takes a day longer to manufacture. I don't care. I want something else than... Where is it? Something else than green. Okay, it seems I'm wrong. That's not an issue at all. I will just assemble one or two. Camera can see correctly. The tolerances, it's like... You do 20 layers, shrink the size then. Not so. Two different videos. Yeah, that is one thing that I could do, basically. But if it's only like 100... something is missing here. I guess they will engineering extract fee, whatever, when I upload my design. So epoxy untinted, no, capped, filled and capped, copper, board tolerance, confirm production file, yes. Do not confirm, yeah, confirm. Oh yeah, do we want gold fingers? Ah, gold fingers, what? Goldfingers is... Huh? No extra? Probably the upmark comes with when I upload the thing. In the end, it will be probably $200 just for getting the boards. Well, what does it cost when I order? Oh yeah, I need to multiples. Yeah, that's cool. Especially, oh yeah, on my last order, so Altium does one thing. If you define in this layer stack up, if you define, oh, so if you have the stack up here, bot stack up, if you define, I changed it right now. But if you define not signal layer but a plane, you can change what kind of not top layer here, the inner layer here. You can change it to plane, so it will be a ground. You just defined its ground, and this whole thing it will be ground. But the Gerber that Altium exports is inverted. So you have all the layers is a positive and this is a negative. So you only get like all your via clearance is only the only filled copper. And they have to notice that. JLC has that in FAQ with the inverted layers that you might need to, the engineer will catch that, but you might need to add a remark or whatever when you submit it, so they will handle that correctly. So I missed that part on my first order of this one here. This is the Altium export with inverted ground planes, and they caught it, and you can always check it. So I was like worried, oh no, my test item might come back shorting stuff or no ground or whatever. But you can download the files. So when you submit it and they prepare the files or whatever, This is the, like, they give you the 48 hours to check it, otherwise they start producing, and you can turn it off. So you have like the time to download their prepared files, load the Gerbers in the viewer. So we have actually, me and the Altium engineers, we have downloaded the files, loaded the Gerber files. You have like a viewer here. I don't know what it's called. Forgot it. You can just import the layers again, and they actually inverted the ground plane layers, so they did it correctly. And this is something that I really want to check the next time when I order the blades. I want to submit it, let them do their magic, download it again, and then review everything thoroughly, and then let them continue and assemble it. Yes, basically that's what I want to do, because if I do that, that's like, and there is something wrong, then if I have a proof that the files work fine, then I can just reorder it or whatever. Probably it is a hidden option somewhere. There are so many options. So the recommendation that I got from an engineer that's working with Altium, not directly, I think he's a freelancer, but he works also like he's really talented. So Jason, if you're watching that, he's a pro. He helped me with a lot of stuff already, like fixing, I had problems like placing that, and I want to repeat, basically showing how you can repeat the layout here and so on. So Jason basically showed me all of that, how to do the parts correctly, if you or clean up all the schematics and everything. So he helped me with everything, and his recommendation was basically don't use the plane feature, just use the signal plane and then place the polygon. And this is basically what I did now, and it's way better, because the issue what I told you about before, when I copy the circuit and the three primitives are attached to a net, the ground planes are always there. So you either do no net or whatever. You can shelve the, probably there are mechanics to turn the ground planes off, or you can ignore them when there is space special. There are like so many features where you can probably work around that stuff. But for me, it is the simplest way would be now to shelve the ground polygons and then paste everything, and then unshelve the polygons, refill everything, and then everything works nice and dandy. But in that case, yeah, there are basically multiple ways of doing things in Altium. It's historically grown. This is the magic software developer term is historically grown. Legacy features, and you don't want like to upset long-term customers if you change things. So you leave the legacy things in, and you just add new features, and then you have like thousand ways of doing stuff. Imagine like a thing like that. I mean, this is like now philosophical question. Would you? This is something that's historic. Probably how Gerbers are handled. If you export them and then you have like very complex polygons or fills or whatever. Oh, you have SKCD comic for that? Let me see. Changes in version. The CPU no longer overheats when you hold down space. Long time users writes, this update broke my workflow. My control key is hard to reach, so I hold spacebar instead, and I configured Emacs to interpret a rapid temperature rise as control. What? Edwin writes, that's horrifying. Look, my setup works for me. Just add an option to re-enable spacebar heating. every change breaks someone's workflow. Yeah, that's basically it. And if there was like a specific reason somewhere back in the time, it might be performance reasons or whatever, that the plane layers were exported inverted, just like solder mask. Solder mask is, I think, also exported inverted, and that's handled as like that everywhere. KiCad, everything. Everyone expects like the solder mask you define basically the exceptions or the removal of solder mask. If you basically the curing of the solder mask is done with an inverted mask, basically, because you light, turn on UV light, you cure, you basically block all the regions where you have to remove the solder mask, or where solder mask needs when you need like bare copper. So everything that's lit with the UV is cured, and there is solder mask. So this is the way basically solder mask is inverted. Historically, probably that's why solder mask layer is inverted. And similarly, probably copper layers were defined this way as well. And then imagine you have this workflow like XKCD comic. You have this workflow, and you have probably Gerbers somewhere flying around. You have like PCBs that you manufacture for ages now. You have probably process in a fab that's relying on that. And then imagine you switch that to non-inverted. So what happens is a cascade of errors. First of all your old Gerber files won't work again if the fab expects now a non-inverted. It's printed now, it depends. Yeah, so either all your legacy files won't work anymore with the fab, or the fab doesn't accept your new files because they're non-inverted. So you have to rely on the fab basically to handle both, to check a version, and like different EDAs started like exporting it in different Gerber versions. How is it defined? Probably there is not even like maybe there is a somewhere a tag in Gerber files. There's like X2, I think Gerber's X2 or whatever. There are different. Do I have it here? There is a production generated. Wait. Documents. No. Did I remove it? So you have basically specified like a process for generating the output files. Yeah, probably there is a tag that says this layer is inverted, but you have also to rely on the fab to basically take the tag and not ignore it or whatever. Changing things in that workflow probably break things as well. Yeah. Anyway, philosophical question. Never change a running system is rule number 1. Even though like it complicates things in future sometimes. So let's get back to work. Let's finish at least some of the traces connecting to the edge connector. And if the assembly is still offline and everything is delayed, oh yeah, I'm soldering when the PCB is powered. Yeah, but you have like a Gerber format, so it needs to be stored in the Gerber format in some way or form, like a meta information. I'm not sure. Okay, you know what? Let's ask Gemini. I'm my assumptions are quite often wrong, so let's ask Gemini. Maybe they have information I don't have. Why are my plane layers Gerber layers inverted? Okay, let's ask it. Photo negative. Oh yeah, you see that? Whole solid blah blah blah, negative plane default. MiCAD tools, Altium, Eagle, KiCad, internal layers, designed plane layers are treated as negative by default. But if it means like default, you can probably change it. Positive layer draw, copper fill, blah blah blah. Because are they computationally lighter? That was my my thinking. In like very complex polygons, because you have holes and polygons with holes or whatever, they are computationally lighter. Instead of software calculating a massive solid pour around thousands of vias, only keep track of small circles. Yeah, performance in Gerber viewer settings, blah blah blah. The polarity flag in Gerber files. Oh, interesting. So there is actually there is a meta info for that, and this is also the format that I exported. I think no, this is the I think I have like the newer format. I'm not sure which one I used. Accidentally flag the entire dark. The manufacturer's software might interpret the copper as air. All right. Fix, double, invert. Look up for checkbox that says invert layer or plot negative to ensure matches your intent. Always include a fab node readme with Gerber files specifying layers. And okay, here we go. So performance was the reason probably. And also negative as from the process. I don't know if you can even read it. Let's not ask philosophical question. Okay, so I should reverse that. Oh, this is I should invert this. Wait, it's Mosi Miso SCK. These should be first. Mosi Miso SCK whatever. They should go on the top. You know what? Is there a holding mechanism? No, I need to add holes or something here. So basically, yeah. Sonic, good that you remind me of that. I should at least you know what? Let's put something on the mechanical layer here. Full circle, so I don't forget this here. Boop. So we have some sort of thing here. There is no, probably a notch, maybe a notch here. but I need a notch rather here. There is no space. This is like 1 millimeter. I can't make the board longer because then they will be touching in the center. Here, look at that. They will be touching like this, like this board here. So the container that I initially wanted to put them in, I hope I will still do it, has an outer diameter of 50 centimeters. So there is a physical limitation that I am bound to. And also, yeah, this is not, but I think this is wrong here. There is the rotation. This tool is lacking. So you see that we have a slight rotation here. So this is not perfect. So if I touch that, removable part on the side. There is no way of adding a precise. So this is this tool. Oh wait, I can put the mouse further away, hopefully. No. Ah! Yeah, this is slow as F right now because come on. Ah! Okay, I give up. There is no, look at that. If I go to panels, properties, there are no properties like orientation or rotation or whatever, physical. It's a little bit, and there are only toggle view. You could specify basically points to match, but I have round corners there on the board, so it's hard. But I think I will use this tool instead. Anyways, let's not do that. I think I should replace those here to go, because they are physically need to go here. I need to get them closer. So unfortunately I did wrong. This order 12, what else do we have? 14, 15. Okay, this is correct. This order is correct. Only this here should be going elsewhere. Sorry, I missed that part. This needs to go on the other side completely. You know what? I will remove them. Oops. Yeah, I think this is a straight one. Yeah. Because this is the SPI, and the SPI goes first. Yeah, sometimes you place it once and then you just reroute because you found a different order is more optimal. Can also remove the ground. Yeah, we can shift him over here. Whatever. This component, I think I will move it. Oh yeah, my rotation step. I will go with like that. You know what? I have plenty of space here. Why not use it? All right. Here. What? Oh, what did you learn in the Home Assistant stream? I don't know the order yet. I'm staggering here anyway, so let's assume. Is this the first one? Whoop, whoop. Why is this ground? Huh? Oh yeah, that's the backside. Doop. Boop. As just I might need to clear the connector though. They are quite strict about that, I'm not sure. Let's every second one. Whoopala. Oh, my headphone is low on power. I hope this is the order. Yeah, this is closer. It's probably the wrong order. Boop. Oh, it's backside again. Opala. Yeah. Ground, yeah, perfect. Top layer. Yeah, new integration. Oh, look at that. Huh. Okay. So this is better than this way around. Whoop. I will shove them later, tidy up. Just need to get it correctly. Oh, now it's weird top layer here. Pop, pop. Wow, look how tiny that is. The traces are so thin. This is a PCI Express connector. Look. This is the connector, the size of the pins. You can't even see here. The traces are so thin. Oh man, I'm so used to work on this scale. The trace width is 1.2, I think here. Let me check. 1.1. Oh yes, that's the inner layer. 1.1. The outers are 1.27. The outer layer. It's so crazy. Okay. This one. Wake up. Okay, let's try Mosey. Plus. Oh shit. Yeah, I will need to swap layers though. This one wants to go in between. Wondering if I can do that. I can do that, but I should reorder this. Okay, let's see how we can do it. Oh, really? Hacker mode activated? Dutch, really? You have that? Oh, that's so cool. Amazing. Hacker mode activated. This is old and epic. Oh man. That's already 10 years ago. Oh, yeah. This clip is from it's like I think August 2016. That's where this clip is coming from. Is it? Oh no, it might be. We had the Romance mode activated is from August, and I'm not sure. Hacker mode might be even older. Hacker mode activated. Yes, 10 years. We are old here. This is crazy, yeah. Peeps, this is crazy. We're doing this for such a long time already. 12 years as this channel in August. 3rd of August, I think it will be. Oh, we can even put it in a pad. Hacker mode activated. Yeah, I need to probably. Oh yeah, this is wrong here. We need to have a ground in between both of them. I will add this later. Function first. But the SPI is done, and now we have 60 more traces. The order, we need to change that order, but this is probably 16. Yeah, these are cool. These are cool. Whoop! Here we go. No live stream goes unnoticed. That's cool. Okay, and then we do black backside here. PB9. Oh, interesting. Yeah, this is pin B. That's like completely different story. We have so much space in between those pins that I don't even need like to fiddle around and give them clearance. This will be plenty space here. All right, and these are the the reset. Look at the reset here. But reset doesn't need to be fast. Yeah, that's why I moved everything. Look at that. I rearranged. If you compare like my first layout of the chip, look at that. This is still okay, but no, this actually I don't need to do a lot of here. I even moved the chip. I extended the PCB by a few millimeters. The grid was basically this the part. This layout looks okay. This aligned better, but I had to change this complete layout. So the two inner layers that I'm using for signals, they would all end here, like on the lower side. So I can basically look at this. This is like the two top layer and these two top layer and these two top layer traces. I had to move everything to the lower corner or here. These three top layer traces. I moved everything to one corner of the MCU to have the space to put all the, this is even more crucial, like these signals here, they have to perform better than these signals here. So this is, theoretically, they perform the same because this is just a step in between. But the bandwidth has to increase. Each hierarchy step up, like this needs to be the fastest, even though we're going through a connector or whatever. We measured that we can run this SPI with 32 megahertz, which is really cool, or megabits. This, I hope we can achieve the same, even though it's like we have already, look at this, this one is like this length, this one is already double, twice the length, and here it's probably not twice the length, but there are like connectors, probably wires in between, so it will be quite challenging. I hope that we don't bog down in the communication and need to like lower the speed more and more so it will be reliable. But I have like plenty of options. We can even do a soft differential. That's why I traced out those here. No, wait, wrong schematic. No, it's also not the right one here. I wanted this schematic here. So I thought these are all the free pins that I have from, so this is the SPI. This is the SPI. So this is the minimum requirement for me to communicate with the upper level. This is hardware based. And what I added is basically, okay, let's have a parallel option, 16-bit, and they're all on port A, so I can write it with one instruction. We can even DMA. This is the option that's really cool for the CH32 cores. The DMA, you can put them on addresses, so you can write to basically the output port over DMA, so we could use that. The only thing is, like, you would need to synchronize the clock, so you have either to limit, if you want to DMA it, you probably need like to use 1 bit for a clock from the register or whatever, I don't know. It will be weird, or you have to time it correctly with a timer or something, timer pin. And I have plenty of other pins. Some of them I left out. So D pin, B2, 6, 7, I disconnected them because I needed the pins for the power. I didn't want to run the pins on 1 amp or something. So I have 32 individual power lines for the small MCUs. So I ran out basically out of pins. That's why I'm not routing everything. And I really don't need everything. But what my intention was, I had, these were like PB 0, 1, 2, 6, 7, 6, 7, 8, 9, 10, 11. So because of the pin count of this specific MCU, it's not the highest pin count. They're like the 100 pin variants. This is the 64 pin variant, or 80 pin variant has like the full PB register, but this one doesn't. So if you consider writing to a register, no, I have too many pins in that case. I run out of pins on the PCI Express connector, but not on the MCU. So I have plenty of pins on the MCU, and I thought, okay, yeah, let's get rid of some that I might not use. So in that case, why would I take PB0, 1 and then 8 and 9 and not PB2? Because this is like, if you see that they're sequential, like 0, 1, 2, and then we have also 6, 7, which is also sequential within the first byte of this register. So we could write those bits all at once. Yeah, most important, yeah. And I took even like that's hundreds. I mean, I want integrity. That's why I'm taking next to the signals, I take like each of the pins next to each are ground, and also the opposing pin is ground. So it's staggered like that. That's in consideration. So this is taking like days or whatever, fiddling around to find out like the best option here. So back to that. Why did I skip like 6, 7 or whatever here? This because if you want a fast communication and you implement a soft protocol for that, or soft procedure, because the CH32V303, they don't have differential communication. The 417 has some differential pairs, but they are also limited to 1 megabit per second. So I know this peripheral is quite pointless. But if I want to implement differential pairs, I could do 2 pairs at once. So look at that. I can take like a differential clock and a differential bit. I put the clock on 1 or 0 and the data on PB1. PB0 is clock, PB1 is data. So it's way faster for me to invert that and put it on PB8 and 9, the data and the clock, with like 2 opcodes or whatever. I can just take the byte, invert it, and shift it by 16, or put it in the higher byte. So this is a way faster operation of implementing differential pairs. That's like all details in this huge design. There are so many like little things that I added just to be sure that I have a convenient way of implementing soft differential pair communication like that. There's also like 8, 9, 10, 11, so I have 2 more if I need them, but they're basically optional. Yeah, I could do even, let's say, the clock on, if I do a different thing, let's say I take the clock on PB0 to 8 on the first byte, then I can invert the first bit, put it on the second bit, and then I could basically take 2 differential pairs on the higher byte here, because I have like 4 bits sequential. I just need to take 2 bits and then invert them, put them on 10 and 11. So I could even do this way. I could do 2 bits data and a clock in differential pairs. So this is why I took that, put it there, but this is all optional. This is all auxiliary here, and yeah, it's all filling that and doing extra work on the layout here. I hope I explained it well enough for people to understand what I mean. Yes. This is the meme. I'm laying in bed and thinking about stuff like that. All right. So this is, yeah, we can leave that. This is basically, this is the reset. We could even just put it, that not needs to be, doesn't need to be hidden. So basically, this is the reset is the least crucial thing. We only need that for programming, or I don't know for what reason we would need the reset pin. I initially didn't even want to root this. I thought, oh, alright, like programming might be interesting. I could even put the reset pad on the back here. Boop! Ha! Here you go. This is for free. Oh yeah, these ones here. Ooh. Yay. Yikes. Where is it pointing? Yeah, these two. So probably... all the RTX break there. Oh, because it's so heavy. Oh yeah, alright. Yeah. We should be careful. Alright, so this is, I think this should be 15, I guess. It's 15. Is it 15? I hope. No, it's not. Is it? What is it? 15, yeah, it is 15. Do we have different ones before that? PB. Where is this one going? Okay, PB. That's A. Okay, let's put this one here. Not sure. PB0. Okay. Where are the other Bs? Oh, the other Bs are on the top. Oy oy oy. How do we do that? Yeah, we need to cross somehow. Yeah, let me do the A's first. And then let's see what happens. Minus. Let me prepare that. So there's probably a feature where you can do that with all at once. All the, like simultaneously, like in an editor, code editor. Only do this side and I will go offline. We have already, oh, it's already, yeah, we're streaming for 5 hours. Dudes and dudettes. Oh, too close. Too close. Yeah, let's move down, further down. Probably I will move the trace as well. Let's optimize that later, function first. Alright, so that looks cool. There's only PB missing. Let me check that. So we have all the traces prepared here. It aligns with my grid, which is really cool. I took, I think, 0.25 grid here. PB11, what is it? Yes. And that's all power, starting from here. Without differential traces, yeah. It might be some hackery there. We just talked about differential, the option of having differential pairs here, but they won't be on the connector, they won't be next to each other. Just for having them, if whatever happens after this PCI Express connector might require it, not sure yet. Okay, let's see if this, yeah. Does it align? All right, that's cool. It's so crazy. This is so tiny. Traces are so tiny here. Oh, that is convenient that the order is correct here. I hope that works out on the other. I jinxed it. Huh? Where's this going? What trace is that? Oh, no trace. Here. Yeah, I don't know if it will be 30 megahertz, but it's all impedance matched and shielded within that. So it's completely enclosed in grounds. I tell you that the only issue that we could encounter is basically some like capacitance reflections maybe, but it's a single-ended not sure, no star configuration or nothing. Really trying to Christian. Okay. Yes, the FGA. Here, look at the chat window on screen. Here in this region. Oh no. The help is not up to date. Why does it read all? Oh no. Okay. That fan spin doesn't work. Most of the things don't work anymore. We reworked our code. Oh. Is this all? No, this is B's. That's these things. Oops. Drilling layer. Where's A5? A0. Yeah, so let's move that here. Whoop! That's alright. I don't care if it's a walking duck animation verbally expressed on TTS. Oh, This is the one. All right. Uh-oh. Where are the other ones? Are still missing? Okay, let me find out where this is going. Wait, this should be then different layer. This layer. Whoop! Okay. This needs to be figured out here, like that. Whoop! Whoop! Let's put. Oh, there will be another trace coming here. Guess what is this? Yeah, PA6. Yeah, it's coming. Just place. I just placed via so I don't forget it later. This probably won't work. Maybe it works. Wait a second. This needs to go. This is wrong. This needs to come later. This is PA7, PA6. No. 7, 6, PA5. DFGA! What did you do? Pitch 1.8, alright, okay. That's hilarious, okay. Yeah, let's just leave it. No! That was cool. I liked it. I liked it a lot. It's a me Mario. That is it. Okay. Okay, maybe if you want to try saying something meaningful or whatever, then it might not be useful. But hilarious it is. All right. Okay, so we have an issue with the color order. So yeah, I can actually understand this mostly. It's a little bit hard with some words. It's cool. I like it. It's funny. Pitch 1.5. Oh yeah, it is. That's perfectly for like a female voice. Yeah, here this chaos. Don't look at this. Yeah, I will solve that later. Let's do. Uppala. Hey, this is. Oh yeah, this. Oh no, I need to change all the orders here. Yeah. All right. Let's do it. Oh, wait a second. Oh yeah. Wait a second. Yeah, you can do this. Deep voice. You know what? We need different order here. Different order, this first. Wait. Yes, I can understand this. Very deep voice, very manly. What is this? What did I do? Completely wrong layer. Ah! Oh no, I have components still on here. Yeah, I need to take PA4. Yeah, long life smoke. Lifelong smoker. Foo. Okay, yeah, I need to shift that a little. This needs to go on layer 3. Why is it doing this? Sometimes it's weird. Alright, now, whoop, cool, that worked. Then, yeah, I just delete this, pointless in that case. A3 is first. Then we have A2 like this, then we have A1 and A0. This is the order. We have plenty of space here left. Oh no, there are some more traces. Anyways, let's do this then. Oop. I hope you don't mind that. No. Huh? Random message boxes. This is something that's an absolute no-go for softwares. Pop-up message boxes. That shouldn't. I mean, if it's blocking error or whatever, then yes. But usually there should be a more convenient way of displaying stuff than modal pop-ups sometimes appear on different screens. This is terrible with KiCad. Like for my multi-screen setup, KiCad is so terrible. It scales. Like if you have a configuration pop-up or whatever, it scales it to the whole desktop. And this is like spanning 3 screens, and one is 4K. Oh, DFGA, it's... Oh, what? Did it break it? Yeah, probably. Oh no! TTS is now completely broken. Yeah. Sometimes that happens. You probably need to restart your browser or something. Chrome completely, the task Chrome. I can't hear you anymore. That's why I will Firefox you, and then I don't have different voices anymore. Yeah, no, that doesn't help anymore. Damn it. I should limit that. Pitch, too slow pitch doesn't work. That breaks stuff. I have now Firefox. Firefox says no. Oh, that's quite speed, the FGA. I can't understand that speed. Okay, here we go. This layer. Uh-oh. Pay? What? No. Why should they pay for TTS? Who should pay for it? Yeah, Chrome is broken. Sometimes with the parameters, I think that happened before, when someone changed the parameters to be really weird, then the TTS completely breaks. Where's this one coming from? Huh? What did I do? Oh yeah, that's the same level here. Okay. Let's move it slightly. Yeah, and I have to change the order. Damn. Alright, so let's take this one. This one. Whoop! Switch to inner layer 2. Then take this one. Switch to inner layer 3, and then we are good. Alternating the layers. The only things missing are the bees here. Bees and bees, more bees. 5 Bs missing. Oh, it's quite, oh, it's quite a lot. Might need to push things around. Does it work if you restart Chrome? Oh, that actually aligns. Here there is an issue. Nice. Yeah. This is working well. Reset. Oh. So what setting was it? Like the super slow speed that broke it? Don't change it again. It will probably break for everyone then. That's I should filter that because weird. Do you know the setting that broke it beforehand? Because we can fix that basically by setting a minimal speed here. Oh shoot. Wait, I need to move it over here. How do I move the bees? Oh no, I need to move them down. It was speed. You know, I need to move it all up. Yeah, I need to move them up. How many do I have space? 1, 2, 3, 4. 4, and I have 5, 3, 4, 5. 5 more. And these two are not the last ones. Ooh. Okay, so speed limit needs to be lower than. Okay. Oh. I should take a note. Ah. Speed, TS, speed, min max. Okay, I will change that so we have like some safety in there. That should be simple. No, two, it isn't two. I'm sure of that. Oh, foo, that B seems to be not aligning well. I'm wondering if we should change the order of the pins here. Put the B, no, but we have also B over here. You know what? We will leave B here and just make it cross. Doesn't matter, we have no components here, nothing. So that will be alright. Yeah. We can also, no, we can also cross it on the back side maybe. Otherwise, we would need to squeeze it in here. I don't see that. Maybe moving those traces over here, but then we have 0, 1, 2 knots, 10, 11. like 4 traces, like 4 vias over here, even maybe over, yeah, these we can't get them in there. Are you British? DFGA? That didn't change anything. Oh yeah, not for me actually. I can't restart Chrome right now. I hear everything in the same voice. So did it change? Maybe it's even like a female voice now. It changed. British. Oh, this is triggering me. Weird. Where is this coming from? What is this? This is a ground pin. Yeah, we don't need that here. So actually I might be able to put it there. This will be weird. Yeah, I can't make them cross anywhere. Look at that. This is red. Yeah, I need to put them all here, like 4 traces. This 3 would probably fit there if I move them around. I really don't want to. I'm because I'm tired right now. I'm not really willing to do extra steps here, but it might be good to do it. Hey, Iconis Kappa. We are making a small project here, a little PCB with a really small PCB with 1024 MCUs, and it's only one of 64 boards. A PCB for ends. Oh, that was off. Sorry, but I pew 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 pew. Yeah. Risk V. And we are currently tracing those here. Beep 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 beep. Yeah. Nah, it's not competing, but it will have more cores than RT. Like the whole thing, if it will have the 65,536 cores, it will have more cores than the RTX what is it, 1590 GT RTX 5090. Yeah, that's the biggest one, is it? Yeah, which has only like 50,000 cores, and this one I will challenge the Nvidia CEO, unless procurement gigahertz. Yeah, okay. Yes, I know they are less, and they have no FPU and 10K cores. Yeah, It's all just marketing. I mean, my board is all just marketing. I just need to have a good title. The budget is $15,000. Oh no! Shouldn't say that out loud. Yes, they have all LEDs. They have all LEDs. Show you that. Do you see this little gray box here? This is an LED. They're all arranged. Oh, yeah, I can show it. I have. So you see. What? 15 what? I can show you. One part of that. 15,000, yeah. Yeah, Voodoo maybe, or certainly, because it has also 2048 FPU cores. So this is basically one part. Ignore that one. That one has a different code, test code. But this is basically identical to this row here, to half of the complete row here. They're just mirror images, not mirror images, but rotated by 180, and one segment, like here, is this row here. Plenty of brightness, 3 kilowatts of power. Previous prototypes, what do you mean? This one, no, or the other clusters with these, no. What do you mean? Like or this prototype which barely works without. No, this was on YouTube, and this one was on YouTube. This is the 256 clusters. Never completed the connectors here though. So this one, that had only like not RGB. This is this here. Cluster, blade, whatever. That one had less powerful MCUs and only one color monochrome LEDs, and these here are full RGB. Yeah, it's 70,000 lumen, because we limit to 1 milliamp max per color component. This is not, we don't want we don't have the power. The cores will take more power. 10 milliamps per core, 3 milliamps roundabout per LED. So it's 13 milliamps per core, and then calculate that like 3 kilowatts is the budget for all the thing. And this is basically what we have as a power supply. So here. Check the stats of this power supply. It's amazing. It's so heavy. It's so heavy. Will it mind? No, it will just light up LEDs. No. Wait. There are plenty ideas. And massive phased array antenna, but then you have to synchronize it properly. No, you can't synchronize 2 point like this gigahertz. How do you synchronize that? You would need like, I don't know, either an analog, either a frequency that is higher than that, or some way or form of doing delays on that. Because if your wave is 2.4 gigahertz, then you need like half a phase shift or whatever between 0 and half of phase to aim it anywhere or do whatever. So I think most of the phase array analog phase array stuff is done in analog. Would probably, it's more wise to do it on PCB in so way or form that you can microwave cooker. Yeah, if you can synchronize them perfectly, like from one clock or whatever, then and put them in parallel, you get basically a beam of 2.4 gigahertz. Is there a resonance? I believe 2.4 gigahertz is so safe that you can't cook a brain with that. Otherwise, we wouldn't use it everywhere. And it's not resonant to water or... Please ask ChatGPT if or check any list that shows you what kinds of... Oh shoot, these two pins will interfere with my stuff. Yeah, I guess we are running out of luck here. I mean, that's getting more complicated. I think I should have a rested brain continuing that, because now I'm moving around the clock pin, the crystal, but this crystal won't be used. I don't think I will even populate it. Yeah, we need to... Oh no, yeah, we need to move around traces around here and revert that. I think I rather cross stuff there. You have the space, but I don't know if I actually want to do it. Here, there's some space to put the B lines in here. If I move it up, yeah, that will work. Okay, let me move it up again. I can't move all of them up, I believe. I don't know. Also, I probably need to put the test pads, program test pads somewhere vertically. 300 watt. Yeah, but does it resonate with anything? Does 2.4 resonate with any material? Oh, def ray. Oh shoot! You're right. Oh, water, fats, and sugar. So basically brain. Okay, not playing around with that. I see. Yeah, do you want like to let me kill myself? Not happening. This is too dangerous for a slob like me. Oh, what? That's so stupid. That sounds like really a bad idea. Who decided that? So that's why Wi-Fi goes down when you cook something in your oven. Ah, this is the last one. Okay, F this. Yeah. What? PB0. Right. Let's start with PB0 then. Okay, that might work in the end, at least for these. Ah, okay, so this behavior. Oh, I pressed save. Save takes 10 seconds. Yes. Yes, we have all calculated here. Do you want to see it? I have a sheet for that. It's 10 milliamps per MCU, theoretically, probably a little bit more for the cores. The power traces here. That's the LED power traces. The other ones are so interesting thing. If you have if you select that, let's say this is that's a power trace for LED that's shared across 4 columns. You can go in Altium. Let me turn that off. You can see basically delay for this trace length is 400 picoseconds. Length is 66 millimeters. Wow. Yeah, 6 centimeters. And maximum current is 2.24 amps in that case. And then this is basically the maximum current. I don't know if we want to go maximum, but we have 4 columns. That is 32 times 4 times 3 times 1 milliamp per channel is 384 milliamps per trace per pin here. And this is what I calculated. Wait, let me not, I need to show you that. Pin mappings, power calculations, right here. This my pin connectors. Okay, so I checked basically what I want to distribute. And this is my calculation on pins. I have a little bit more than 32 because there are like the controllers on the side have also LEDs. So we're distributing amongst 8 pins, and this is basically the current that it will draw. Same with VCC. Most crucial ones are VCC 0. We have 10 milliamps per MCU there. They are a little bit lighter if you run them from SRAM, all the MCUs. But basically, we have a lot of headroom there. We have 10.24 milliamps. How do I calculate that? Yeah, this I think from the data sheet. We're distributing amongst like the 1024 MCUs, distribute over 32 pins actually to have a constant, because this is crucial. We have a constant power draw on the MCUs. We can put them in sleep or whatever, but why? Why would we put so many MCUs if we want to put them on sleep? So this is basically constant power draw there. Same for the other ones, which are not much. This is what I The bigger MCUs are quite low on power. I think they take only here 22 milliamps for the bigger ones, with with FPU and so on. So not so power hungry, and we take 4 pins for those, which only have 170 milliamps constantly, but a third of an amp per pin constantly. It will probably like create some heat, and since it's within a connector, the heat needs to be transported through the PCB, ground planes, whatever, away. This might be an issue. Yes, but Basil, we have to consider that PCI Express has a better spacing between the connectors, probably also better. There's a lot of considerations, and I want this headroom. I never would take. I mean, I had made boards before where traces or pins were transporting 1 amp, and it's not good. It's heating up, and you need to like dissipate this heat, and I don't want to take care of that too much. That's why I try to limit it. Oh, we have a clip. With a really small PCB with 1024 MCUs, and it's only one of 64 boards. Streamception. PCB before ends. Oh, that was off. Sorry, but I. Pew 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 pew. Okay, cool. Thanks. That's cool. Thank you, Iconis. All right. This year, the highest amount is 0.4 amps, but this is maximum. And since we have a PWM, hardware PWM on the LEDs, This will only occur if we have full brightness white on all of the LEDs at the same time, which is alright with me. We have dimmed anyways all the times. Sometimes you only show one color at a time, like this fading that I'm doing here. That's only like two components, two one color components, so it's more like 200 milliamps most that we're drawing per pin. That's all right. So everything is considered here. Full brightness. No, not full brightness. I limit it to 1 milliamp, which is the sweet spot here. They are going up to 20 milliamps per color component, but they will heat up. They die from heat. They will desolder. Like, how do I? And I don't have the power. So the cores are taking so much power. If you calculate it, we have 3 kilowatts. So we have 3 kilowatts divided by 64 boards. We have 46 watts per board. And then divided by 1024, because this is the maximum I can get from the outlet and from the power supply. There is, yeah, but yeah, the outlet, it will trip the breaker if I don't have like two phase or different breaker or whatever. It's just complicating things more. That's my limit. So I've 45 milliwatts, and if I divide it by 3.3, then we have 13 milliamps. It's just spot on. And this is at 3.3 volts. We could run the course at 2.8 as well as the LEDs, and that's what we try to optimize basically for the conversion losses that we get also from the power supply and so on. But this is already at its limits, peeps. We are at its limits here. All right, it's quite late already, peeps. I will do I'll do the two traces here that we're missing now. Yeah, that's a thing that we need to figure out. We already plenty of little buck converters. Each of the connector will have a socket next to it where we can plug in little buck converters. Oh, we're done here. Nice. Okay. Oh yeah, that actually works out. What I will try to do is to move the traces up here, but this is just optimizing to basically give that a relief here. This is going too far down and then up again. So I will try to get those vias up here and these traces shorter. Looks fine. Right, I think. Yeah, either that or submerged cooling. That's why it's arranged like this. The controls, I never get used to the controls. How do I rotate again? No, don't move this. Yes, it has auto routing, but I don't want to use it. I have a specific layer. Look at that here. This is in the shape of a container. Peeps, I'm done for now. Yeah, very interesting. Look at that. Oh, what? You couldn't excel on that exercise? What? Why? What? Here, I will show you the design that came for raw chicken. Yeah, the hole won't be that big. It's just the connector is like, look at this. This was before I started to design any board or anything. Look at that. This is the mock-up that I made before designing the board. So this is basically from affordable container that you can purchase, an acrylic container that's closed is 50 centimeters is the diameter that it's affordable, and it's already 400 euros for this container. And I can submerge cool it if I put it this way around, or I can vent it. The inlet will be in the center. Here there will be a hole, and the outlets will be on the sides here. Boop, 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 boop. So the air should be then moving around like that, circulate. I don't know if it, or we just remove the container and hope for the best. This is 3 kilowatts of heat. I don't know. This must be like, I will put a huge fan on top of that. I would take like a regular ventilator. I will just take this one here. What's the diameter? I will just take this one and funnel it down. Like what? 150. Yeah, we need Vevor. Yeah, that's my best ones. Yeah, this is what I will put on top of it. I can, if it doesn't work, I mean, we can figure it out. If I move away, let's say it doesn't work, the cooling doesn't work, it heats up too much. We have spin it. Yeah, that the problem is we need like power from a slip ring or whatever, USB with a slip ring or what. Temperature sensors are built in the MCUs. All the MCUs have temperature sensors. So we have the best temperature sensed board ever. There are 1024 temperature sensors plus the 32 plus the 2. So we have 1050 temperature sensors all over the place on each board. And we can monitor the temperature there and basically shut down when we see not working, not great. We put everything in standby. This is basically it. So if the cooling from the bottom doesn't work because we have like extra electronics, we need to funnel down stuff, I will just put a frame around it and aim a huge ventilator downwards, and it will just vent like that. Yeah, I know. It's powering from sibling. Oh, this vertical tower coolers would work in the vertical tower coolers. What is vertical tower? Can you link one? So this is the idea, and we are working our ass off to make it happen. I just hope the blades are so crucial. I should divide and conquer even more like I did before. I just like small pieces and plenty of those. Dyson, yeah. But terrible. I don't want big noise, like these annoying noises. All the high-pitched noises. A turbo ventil. What is what is the things that do vacuum? My former housemate, he had like a turbo vacuum chamber. Ah, oops. Oh, Sonic, you gave me the certbots thing. Thank you. Oh, the tower coolers, yeah. And then 64 of them right around it. Tower coolers. Yeah, I will find a solution. In the middle, yeah. But we could also just make it somehow like a 3D printed part that we stick in the middle and then let it distribute. There will be a hole, so I don't mind. Okay, peeps. Sure. I'm done for today. I'm tired. I can't even see anymore. All right. We did some routing that I'm more or less satisfied with. I will optimize it, put grounds everywhere, and then copy here, do the power, and then DRC checks. Yeah, here we go. Thank you for joining. Thank you for the subs and the donations and everything, and for the contribution. And I hope it works. I hope it works. I just hope it works. Everything else, if the PCBs aren't expensive, we can let them assemble one, two. I think the minimum was 2, you said. And then see what happens. But if I lose so many parts, I don't know. Let's see what happens. Peeps. Oh, next week I'm at people who missed that part. Next week I'm on Embedded World, and my train goes back at 18 o'clock. So the stream either will be postponed to another day, no, not Thursday, or later in the evening. So it will take me probably 3 hours to go back. Oh, I don't know if I can make it. I will arrive at home at 9 probably. So next week I will think about a solution, but I will be at Embedded World. If you want to meet me, poke me on Discord or whatever way you find out. And I'll see you next time. Bye bye.